This is the KCSE Mathematics Paper 1, that is KCSE 2025. I don't know how you feel about the paper, but I'm actually from talking with more than 200 students who sat for this exact paper. And let me tell you, minor, this paper is a bit so dangerous. To some extent, there are some questions that are a bit so much sweety and juicy, but actually that's where the problem begins, because so many questions in this paper look so much innocent and so much easy, but deep down in them, there are so many tricks that have been hidden in them. And therefore, I decided to take my time to record this particular tutorial, not only to show you step by step on how to tackle on each and every question, but even to do something that is not usually done most of the times, and that is getting to reveal the mind of the examiner. So therefore, what I'll be doing is that I'll be getting to reveal the mind of the examiner, getting to share with you how the drafts were formed and how you can be able to avoid them. So it's very important that we get to follow keenly from the start of the video until the end of it, without skipping, so that you can be able to grasp every concept that I'll get to share all along. I believe this will make you to be much confident in mathematics. And actually, let's get right away into it. We have our question 1 right here with us, and we are told, without using mathematical tables or a calculator, evaluate this expression that is right there, and that is the square root of 11 over 12 minus 1 over 3 divided by 1 over 2. Well, you see, you have been told that you are supposed to evaluate this without using mathematical tables. So by just getting to watch on this, that already communicates something, and that is the examiner is telling you, in other words, that what they are so much interested in is not the answer that you get, but the process that you do follow. Therefore, the things that you write, you have to write them in a way that shows that you never used a calculator. And let's go ahead and work out that. So we have 11 over 12. Well, you see, this is fraction, a fraction, and also this one is a fraction. But, well, we can be able to convert this one from a combined fraction to its a proper context like the other. So we have minus 1 over 3. And then what we do here, we have the division sign. So to be able to convert it into a proper fraction, what we do is that we have 2 multiplied by 1, we get a 2, plus 1, we get a 3, and then we have divide by 2, and remember we've got a square root here. And you see, when it's like this, there's so many students who usually go ahead and just minus here, and they say this is 11 over 12 because this one is a multiple of 3, and here we've got 3 here. Therefore, this one is much easier to do the minus, and that is a very deadly mistake. You see, everything that we have usually have protocols. Even when we are having gatherings, you will see if it's a political gathering, you'll see the MCA speaking, and then MP, and then the governor, and then the CS if they are there, and then finally the president. Also in mathematics, as we get to work out these operations, there is a procedure and a protocol that we should always apply, and that is definitely none other than BODMAS. Very important. Therefore, what we first do is not what appears first, but what appears first in this structure that we use, and that is BODMAS. Since we don't have brackets, we don't have off, we simply start with the division. Therefore, we start with this part over here, and we apply a simple law that whenever you've got a division, we usually change the sign, especially if we are having fractions on the left and the right side of it. We convert that one to a multiplication, and then we invert what comes after that sign, and that is this 3 over 2. Therefore, we reciprocate that, and once you do that, you are going to get 2 over 3. Everything else remains as it was, like that. And remember, don't forget this square root sign. Finally, we can be able to do this multiplication. We have 1 over 3 times 2 over 3. We can multiply the numerators, that is 1 multiplied by 2, that's gonna give you a 2, And we have the denominators as 3 by 3. That's going to give you a 9. The question is actually becoming a bit much simpler because here we have now 11 over 12. Therefore, we just simply write it here, 12. And then we have square root. Great, amazing. So we are having 11 over 12, and this one you are supposed to minus 2 over 9. What we use here is that we try to find the LCM of these numbers, 12 and 9. The LCM of these numbers is 36. Therefore, we do 36 divided by 12. That's going to give you a 3 multiplied by 11. That's going to give you a 33. And then we've got a minus 36 divided by 9. That's going to give you a 4. And then a 4 multiplied by a 2. That's going to give you an 8. And remember what you have there is a square root sign. You have to carry it all along. So this is like a key that is giving you access to each and every step. If you forget it, then also the marks that are here, you are likely to be penalized on that. So we have 33 minus 8. That's the same as 30 minus 5. That's supposed to be 25 over 36. And we have the square root of that. So finally, we complete up this step. So we find the square root of each and every component. We can find the square root of 25. That's going to give you a 5. And the square root of 36. That's going to give you a 6. But unfortunately, many students just left it at that comfortably and said, finally found the solution. Don't make this mistake, because each and every time that you are finding the square root of something, always remember and know that the square root of something is equals to positive or minus the results that you get. Therefore, the required solution is supposed to be plus or minus 5 over 6. If you just leave it at 5 over 6, then you are going to lose the answer mark. Therefore, you are just going to get 2 marks. So that you are really able to get the full marks, then you should be able to really be able to write plus or minus 5 over 6. And then the other 2 marks, you are going to get them along the procedures. The first one being able to work out this part, that is being able to convert this sign to a multiplication sign, and then being able to reciprocate that, and then finally being able to get to a point where you are going to the second step of now minusing in order to be able to get all your full marks for that. And that is how you are supposed to solve that question. And normally, question 1 usually gets a very easy question, and this is the psychology of the examiner, though this is something that is not usually spoken about. Normally, they'll give you just a simple question so that your mind can really relax a bit. And when your mind really relaxes so much, what usually happens to you is that you don't become so alert, and therefore you are likely to make up some simple mistakes like this one over here. So ensure that you don't fall into that trap by ensuring that you are fully alert and you remember all the concepts that you were taught. Let's get into the second question over here. A very awesome question. I see it's touching a bit about money. And we have Baraka earns shillings 210 per hour working at a supermarket. The employer changed the amount earned per hour in the ratio of 8:7. Determine the amount that Baraka would earn in 10.5 hours at the new rate. You see, this question really contains a lot of sentences, but now it is your work as a mathematician to be able now to simplify all these. And that is why you usually say that as we do mathematics, what we are doing is that we are finding the solution, and finding the solution of something is getting to move from the problem to now the desired solution that it's supposed to be given as an output. And that is exactly what we do. The first thing to know is to determine the new payment. You see, this one was the old payment, that is 210. This is old. That is shillings 210. We need to determine the new one. You see, the new one is now 8:7 of the old one. And you see, when you've got a ratio 8:7, that implies that it is 8 that has been divided by 7, but then we are multiplying that with the old value because this is now the new ratio, the new and amount, which is 8/7 multiplied by 210. I believe that we can be able to handle this because divide by 7 1, divide by 7 3, 0, 8 times 3, that's 2 4. So the new amount is shillings 240 per hour. This is very important because we are having him being paid shillings 240. This one is per 1 hour. But the question is asking us about 10.5 hours. What about 10.5 hours? Therefore, simply what we do is that we do cross multiplication in order to get the amount that is going to get. Therefore, that's 240 multiplied by 10.5. Wow, amazing. This is really so cool because we can be able to convert this one in a way that we can be able to do the division quickly. So we have 10 multiplied by 2, that's 20 plus 121/2. What we have here is divide by 1, divide by 2, 120. And finally, we get to do 120 multiplied by 21. That's going to give you shillings 25, 20. And you realize this is really interesting. So this is actually the required solution for that. If you do that, then you should really be able to get all the full marks for that. But you realize that here, there was a very serious trick over here. Because you see, there are some students who took this ratio and said that what you're really supposed to do is that you are supposed to take this one, the number that is here, 7/8, and then you multiply that with 210. And you see, the amazing thing with this is that you'll just do, so what they did is 210 divided by 8. What do we get with that? It's going to give you 26.25, and then they went ahead and multiplied by 7. You see, if you do this is very wrong. So what you're really supposed to check is about this ratio. If this number that starts here is bigger, then that implies that the final amount that you get here, which is 240, it should be bigger than this one because this is an increasing ratio. If it was a reducing ratio, then that would imply that the amount that you get here would have been smaller. And you see how serious it is when it comes to calculation, because imagine the person who was doing this calculation is an accountant, and now this is a guy who have been employed somewhere, and now it's supposed to be paid a new amount after some calculations have been done. You see, this accountant, if this accountant makes any mistakes, therefore that implies that he would make this guy who is here to just suffer for nothing. And this is what we call mathematical robbing. You see, mathematical robbing, this is where you rob a person very easily, without using even force, without using a gun, but by just doing wrongly calculations. Sometimes maybe calculating an amount that the person is supposed to be paid, and then you remove the last zero, which is quite significant. Let's say a person was supposed to be paid 520,000, and then along the lines you just remove 10, and this sounds to be a very simple mistake, and this is likely to happen. So you'll find like this amount will now become 52,000 just because someone just did a very slight mistake. And that is why in mathematics, when you make a mistake, even if like you opted out this 0, or maybe you left this 2, therefore you will not be given the final answer is correct, because we also really need accuracy in your final answer, because we really understand how that is important and how that really plays in a real life situation. Let's get quickly to the next question over here. We are told solve for x in the equation 4 to power 3x multiplied by 8 is equals to 1 over 32 to power 2x minus 3. Wow, this really looks so much interesting because these individuals are what we call numbers. Normally, I love treating numbers like people. You see, if these were people, then I would say that these people are somehow like siblings because there is a way that they are really related, and that is they share a common number, which is a multiple to all, and that is 2. Therefore, we can try to convert them to a multiple of 2 so that we can be able to equalize them so that they can look a bit much similar, and that is how we start creating patterns. Therefore, instead of writing 4, what you're really going to do is that we are going to write 2 to power 2 over there, but then don't forget what is here, that is 3 to power x. And then we have that multiplied by 8 is equivalent to 2 to power 3. And then on the other side, that is on the right side, we have 1 over 32. You see, 1 over 32 is equivalent to 1 over, this is 32. 32 should be equivalent to 2 to power 5. And then we have all that to power 2x minus 3 like that. Amazing. So we can go ahead and try to open up these brackets. The law that we are really using here is this law, that is, if you have got a to power m, and that is multiplied by n to power n, then this one is equivalent to a to power mn. This is the law that is being tested right there. And that is what we get to apply here. So we have 2. So we do 2 multiplied by 3x. That's going to give you 6x. That sounds better. We have 2 to power 3. But then if you look at these, something interesting over here, you're going to notice that, you see these guys, it's like this is like a house, and you find like these guys are there in the ground floor, but there's this guy, this fellow over here, is there in the underground. Why don't we just bring him to the ground floor also? And we can really be able to do that. But now as we do that, there's something that happens, and that is when we get to apply this law that whenever you got 1 over a to power m, this one is always equivalent to a to power negative m. So when we are shifting something from the denominator to the numerator, what we usually do is that we usually negate the power. Therefore, as this guy gets to transform from here to move upward, there's something that is going to happen, and that is we are going to add him something over here, and that is we are going to give him an opposite sign to which was here. So if this was 2 to power positive 5, it's gonna be 2 to power negative 5, and everything else remains the same, 2x minus 3. So we can go ahead. You see these guys, they are now a bit closer, and if they are a bit closer, and you see how I was telling you that all these individuals, they are really related because we have 2 to power something now, and 2 to power something, 2 to power something, which makes our work much easier, because now what remains is that since they are fully related, we can put them together, and once we put them together, they are going to share a common place, and the place that they are sharing is 2. But because they have come together, what we do is that we bring them together as they are, and that is 6x. We bring also this other individual together, and we add them together like that, and remember they are sharing a common point too. So there is a law that you are really applying here, which is quite important, and this is the law that we are applying. I wanted to really get to write these laws for you somewhere so that you can easily be able to copy, and that is when you've got something like a to power m, and it is multiplied by something to do with a to power n, that one will always be equivalent to a to power m plus n. This is the law that is being tested over there, like that. So what we do is that we retain the bases, of the numbers, which is a, and then we add the power same plus n. We retain the base, which is 2, and then we add the power 6x plus 3. And then on the other side, what we have is that we have 2. So what we get to apply here is again this law that we have here. That is a to power m to power n is equivalent to a to power mn. So we have -5. And here you have to be very careful because of the signs that are here. So we have -5 multiplied by 2x, that's going to give you a -10x. And then this is the part to be much careful in. You have -5 multiplied by -3. That should give you a positive 15. Because this is actually the part that many students made quite a lot of a mistake right at this point. That is -5 multiplied by this part over here, because there are students who just took this is a negative here and then they just did 5 times 3 and they wrote -15, which is really so much wrong. Since we have these guys like this and they are sharing rooms that are really opposite to each other, but we say that these people, you see that they are related because this one is a 2 and this one is a 2, and this is their kids, this is their kids, this is their kids. So we can also say that their kids are also related. That is 6x plus 3. We take the kids as they are, 6x plus 3, and on the other end we have -10x plus 15. Mathematically speaking, the law that we apply here is that when you've got a to power m and you see that this one is equivalent to 2 to power a to power n, then that implies m should be equivalent to n. This is another law that you should note down like that. So finally, what you do in this equation is that you try to simplify that. We can take -10x to this other side, and it changes the sign to a positive 10x is equals to, we have 15 here, and then we minus this 3. What you are doing here is taking 3 to the other side, it changes the sign. We have 10 plus 6, that's going to give me a 16x is equals to 15 minus 3. That's gonna give me a 12. We divide by 16 on each and every side, divide by 16. When I divide this by 2, I get a 6. When I divide this by 2, I get an 8. When I divide by 2, I get a 3. When I divide by 2, I get a 4. Therefore, finally, what I get is 3 over 4. But also, you can also write 0.75. So if you give your final answer as 0.75, that's correct. If you give it at 3 over 4, that's also very correct, because it was not specified whether you should give your final answer in terms of a decimal or in terms of a fraction. So if it's not told, you can always leave it in either of them. But the most important thing here to note is this formula that is right here, and also this formula, and also this formula, and also how to apply that. Because if you just get to master these formulas and you know how to apply them, then working through this is much easier. And another thing is always to check on whether you can be able to convert these numbers into a similar base as we did by converting all the numbers that we had in terms of the multiples of 2. And that is how we were really able to get to a point where we are really getting the solution of that. Let's move ahead. I believe that you're really learning and that you're also getting to see the formulas that you're really supposed to apply together with the areas that were a bit tricky and where many people went wrong. For this particular question, it was this part of getting to open up the brackets. Always be double keen and double alert. So let's proceed on with our question 4. I see this is a very wonderful, interesting question as well. And actually, as we progress, ensure that you have really subscribed to this channel so that you don't really miss the tutorials that we get to upload. What we're having here, this is a question that really somehow looks a bit different from the actual questions that are usually tested because of the format that it has. But the bottom line is to ensure that you get to work on these cases independently and then later on get to combine them together. Let me go ahead and explain that to you. So you'll notice that before we move on to that step, you'll notice that what we have here is simply a number, but here what we have is a fraction, and here we have a variable x, and we have now a digit and a digit. So the first thing that we do is to really find a way of eliminating these three. You see how it looks a bit unorderly, having something that is a fraction and then the others are numbers. So what you do is that we multiply everywhere by 3, and that is exactly what you're going to do. So we multiply here by 3, we multiply here by 3, and also we multiply this part by 3. Let's go ahead and do that. So what we get here is -1 multiplied by 3. That's going to give us a -3. We have less or equal to, this 3 cancels out to have 5 minus 2x is less than. We multiply this by 3, that's going to give us 6x. You know, when we are multiplying this by 3, we are multiplying basically everything that is inside the brackets. So we have 3 by 2x, that's 6x. And then we have a minus 1 by 3, that's going to give you a 3. I don't know if you remember a certain case that was there of a certain king by King Solomon, where there was two mothers who were fighting for the same kid. And then, do you remember the argument of King Solomon? King Solomon said, or rather suggested to both the two mothers, whether they could just split the kid in order to see how they would reason, and that would help him be able to tell who the mother of the child was. And definitely one of the one of the mothers who was claiming that the kid is hers, what she said that, wow, yeah, we should split the kid because none of us has accepted one to take the kid. And then the other mother who was claiming that the kid is hers said that no, we cannot split the kid. And I don't know if you are that king, I don't know the approach that you could have used. But now here is now mathematical stuff that you are really solving over here. But this one, what we are having here is that we are having a number on this side, -3, and also another one on this side. And we want to split them a bit. And we cannot divide this one into 2. We cannot say that this part is going to go with 5 and then this part is going to go with -2x. It's not possible. But now what we do mathematically is that we create a fair scenario where we take the whole of this case up to there. We say that you who is fighting for this kid who is here, we are going to give you the kid, and also the other person who is on the right side, we are also going to give him the kid also. Therefore, what really happens is that we end up having these cases, and that is -3 is less or equal to 5 minus 2x. And similarly, we also retain this. It's kind of like this number figure over here has been duplicated. Therefore, on the right side, we're also going to have 5 minus 2x, because this one is a relationship, 6x minus 3, like that, such that we are going to have two inequalities. We have the first inequality there and also the second inequality there. So that now what remains for us is now to solve the two inequalities, and then after we get the solution, we'll then get back and try to combine them. So for such a case, what do we have? We have -3, we have 5, we have -2x. So we can try and push this -2x to the other side, and that's gonna be a positive 2x. We have the sign there, and then we have 5 plus 3. We pick -3 to this other side to have it as +3. So finally we have 2x is less or equal to 8. We can divide by 2, we can divide by 2 there, and that's gonna give us x is less or equal to 4. let's go to this other part over here. What's the best approach to go about that? In order so that we can get rid of trying to deal with negatives a lot, we can take this 2x to the other side and negative 3 to the other side, such that on this side we are going to remain with 5, and then we take this 3 to this side to have positive 3. The sign remains the way it is, that is the inequality, and then on the right side we are going to remain with 6x, and then we have negative 2x, we pick it to the other side, we have plus 2x, and finally we have 5 plus 3, 8 is less than 6x plus 2x, that's 8x. We simply divide by 8 to get 1 is less than x. So finally, which inequalities do we get? We have this inequality over here, and that is 1 is less than x. So we have 1 is less than x, and this other one we have x is less or equal to 4. So these are the two inequalities. But if you really check at this very keenly, there's something that you are really going to notice over here. And that is, you have this x over here and this x over here and this x over here. So if you can put this one together such that you have a combined inequality as it has been outlined, therefore you'd have something like 1 is less than this x. At the same time, this x which is here, this x, it is less or equal to 4, like that. And actually, that's how really you are supposed to solve about that question, and that is the required solution. If you are really able to follow all those steps, the procedures, then you should really be able to get your full marks for that. One, for getting the first inequality, the second one, and also being able to put them together, all that accumulates to the 3 marks that you're really supposed to get. But the most critical part is to be able to first convert this inequality in a way that we don't have fractions, and after doing that, being able now to subdivide it into 2 inequalities such that they are mathematically correct. Remember what I said, that you cannot split this one right here and say that this negative 2x belongs to the right side and 5 belongs to the left side. No, you cannot do that. That is a mathematical injustice, and that is a crime that is quite punishable, because when you go out there, you'll start saying, because there's a kid and there are some people who are fighting over that kid, you'll say, let's just divide that kid into 2. You see, that is really, really totally wrong. Yeah, but let's keep moving on. We have our next question over here. That's really question 5. Remember, this is KCSE Mathematics questions that were recently tested. Therefore, this is a KCSE standard exam. We have the following figure represents a rectangular farm PQRS of length 210 meters and width 120 meters drawn on a grid of 1 centimeter squares. The dotted area inside the farm represents a flooded section. Estimate in meters squared the area of the farm that is not flooded. Oh, this is quite unfortunate for the person who owns this farm, because it's really getting flooded, all this section. Therefore, that implies that almost all of this land gets into some sort of a waste note unless they find a solution. But well, that is the concern of the farmer. Us as mathematicians, our concern is to be able to estimate the asked part, and that is the area of the farm that is not flooded. And there's something which is quite unfortunate. You see, normally when you see these kind of questions, a lot of students, I don't know what really happens in their mind, but they ran and rushed to just calculate the estimated area of the dotted part. I don't know if it's because it occurs by default that when you've got such a shape, you're supposed to find the area of the shaded part. But now here was a trick, and that is why you have to be really so much keen as you read the question, because it is telling us estimate in meters squared the area of the farm that is not, this word is very important, is not flooded. Therefore, the part that you're really finding is the part that is not flooded. But how do we get to estimate this? Normally, you'll find like here we've got a section of a square that is flooded, a section, a section, a section, a section. So normally, we usually take the full sections, and then let's create some space over here. So we are going to take the full section over here, and that is this one, and then we add with all the other sections that are not full, and then we divide by 2 to convert them to full sections rather. So we have the first one here. This one, it is full. Therefore, we take it the way it is, like that. For these other ones, we are just going to take the ones that are not full. So we have the first one here. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, the sections that are not full are 12. We have to divide by 2 so that we can get the value of the full sections for that. So this one is going to give us the value of these sections, or rather their area, in centimeters squared. So let's go ahead and add this. This is 12 minus 2. What's really that's supposed to give us? That's supposed to give us a 6. 6 plus 1, that's 7. Therefore, that's supposed to give us 7 centimeters squared. But we are not yet done, because what the question is telling us is that you see, the following figure represents rectangular farm PQRS of length 210 meters and 120 meters drawn on a grid of 1 centimeter squares. You see, this is 210 by 120 meters squared. So this is 210 meter by 120 meters. This one is represented by how many squares? 1, 2, 3, 4. 4 by 1, 2, 3, 4, 5, 6, 7. 4 by 7. So we can actually start by this. This is 7 times 4. That's 28. So this is 28 centimeters squared represents, this is 210 times 120. 210 times 120, that's giving me 25,200. 25,200, and that is meter squared. So we ask ourselves, what about 7 centimeters squared? 7 centimeters squared. We simply have to do cross multiplication. So therefore, you're going to do 7 multiplied by this figure, 25,200. And then we divide that one by now 28. We divide by this 28. That is going to give us 6,300 meters squared. So notice that now this one is the area of the shaded part, and that is the flooded part. Flooded part. So to get the area of the part that's not flooded, Many students may have been tempted to leave it at this, which is really wrong. So don't make that mistake. So to be able to find the part of the shape that is not flooded, we do the whole shape, which we found to be 25 to 100. And then we minus 6300. What do we get by doing this? 25 to 100 minus 6300. That's gonna give me 18900. And remember to put the units, that is in meter squared. And that is the exact required solution for that. And well, this is the easiest way to work it out. However, there is another way that you can use to find the solution of this, and that is you can calculate directly the area that is not flooded. But how do you do that? So you'll start by taking the full squares, like this one: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Do we have any other one that is full? Not really. So you'll just take that 15 and then you add to the other ones that are not full. The other ones that are not full. So there's this one. We could have used a different color. The other one that's not full, it's this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That are 12. Yeah, it's actually, there are 12 of them. And then once you have that, you're going to do 12 minus divided by 2. And then the value that you get there, you are going now to have it as in terms of centimeters squared, and then you are going to now convert that one using this scale that we have here to be meters squared. And actually it will be a nice exercise if you get to try it on your own, to see if it will give you an exact value to the other method, but definitely it should. So that is it for that question 5. But the most important thing is to be able to read the question carefully, to be able to understand what the question is asking, because this is the part that was really so much costly. And then from there to be able to calculate well the squares that are there. But this is the most straightforward way to go about that. Though this is a question that is not really so much tested, but it's a good question to test on your logic and also to test on your alertness and carefulness as you get to tackle mathematics questions. Let's move on to another amazing question, question 6. And actually, I really love this question, and let's get into it and you'll be able to understand why. We have a relief organization donated to 40 kgs of maize and 150 kgs of beans to needy families. And then the question goes ahead and tells us that each family received exactly the same quantity by mass of either maize or beans. And then we are told that no family received both. We are then told determine the least possible number of needy families. The reason that I say that this question is a very interesting one and a very juicy one, it's because you see, determine the least possible. So the moment that many students saw this least possible, they actually never gave it even a second thought. And this makes this question to be very dangerous, because they saw that this is asking about list. The list is just about LCM. And then they just went ahead and just worked out the LCM of these, and then they said, that was really quite so much simple, and then they thought that they got the 3 marks. But unfortunately, by doing that, you don't even get a mark. Why? Because you've even done it wrong, even in the first step. This was testing on your logic and how best you can be able to reason on such a situation. You see, if we are really supposed to get the least possible number of needy families, then that implies, so that we can get the least possible, then we should be able to divide these numbers by their greatest divisor. And that is where the trick lied for this question. Therefore, this question required you to first find the greatest common divisor for both 240 kg and 150 kg. And let's go ahead and do that first. And then from there, I'll show you what to do next. So we have 240 and 150. We are finding the greatest common divisor. So we divide by 2, we get 120, we get 75 there. Can you divide by 2 again? Not really, because 2 is not divisible by 75. Therefore, we just have to put it at that. Then we check out on the next number that we can divide with. So the next number is a 3. So we divide by 3. Here we get a 40. I believe 75 by 3 it's 25. And then finally we divide by 5. We get an 8. We get a 5. There's no any other number that we can really be able to divide with such that we are able to get a whole number. Therefore, the greatest common divisor, it's supposed to be 2 multiplied by 3 by 5. And that's gonna give you 5 by 3, 15 by 2, that's 30. So these are 240 kgs where let's get back to the question. It's really very important. A relief organization donated 240 kg of maize and 150 kgs of beans to needy families. Each family received exactly the same quantity by mass of either maize or beans. No family received both. Determine the least possible number of needy families. So to be able to determine this, therefore that implies that these 240 kgs were divided in terms of 30 kgs bags. Similarly to 150 kgs, they were divided in terms of 30 kgs bags. So to be able to get these families, the families that got maize will be definitely 240 are divided by the number of bags. So these are the families that got maize, and the families that got now beans will definitely be 150 divided by the number of kgs per bag, because the total number of bags are 150 and they are divided into smaller units of 30 kg, 30 kg, 30 kg, 30 kg, and so on until we have a total of 150 kgs. So to be able to get the number of those smaller 30 kg, we definitely do 150 kg divided by 30. So these are families that will receive beans, and these are families that are going to receive maize. And in order to get the total number of families that received both, we definitely have to add the results. So we have 24 to 40 divided by 30, divide by 10, divide by 10, 24 by 3, we get an 8. Here by 10 by 10, 15 by 3, we get 5. I believe that's so. And finally, we have 8 plus 5, and that's gonna give you 13. And remember, these are families. And that is how you are really supposed to go about that. At first, you may see this question and think, oh, these are very simple, easy question. And you just go ahead and just find the LCM, just to find later on that that is not what you are really supposed to do. You are really supposed to really read the question correctly and being able to argue out well, and do so that with the mathematical principles that are going to help you to work out that correctly. So with that, let's move on to question 7. And these are questions that can also land you into trouble if you don't get to check on it quite well and with a lot of carefulness, because it can be an atomic bomb to you, because there's someone who may be tempted to just come at this question and just check, here we just have an x squared, and then they just cancel it out. We have an x squared, they just cancel it out. We have a y squared, we just cancel it out. We have a y squared, we cancel it out. And then they say we have 4 divided, we have a 4, they divide by 4. We have a 4, divide by 4. And then they say, this one is just equal to negative 1 over xy. And they say, that was really pretty, it's just 3 marks, but just doing that and you get your 3 marks, which is definitely totally incorrect. So the best thing is that you're going to do some surgery to this equation in a way that you're really going to separate the upper side from the lower side, and that is what we call the numerator and denominator. So we start with the numerator. Numerator, we are having x squared minus 4y squared. So what you're going to notice for this is that this one is a difference of two squares. Just as we have a case like a squared minus b squared, this case is always supposed to give you a plus b multiplied by a minus b. So definitely what we do is that we find the square root of this, that's going to give you an x, and then you put an addition sign, and then you find the square root of this, and you find the square root. You are supposed to find the square root of all these 4y squared, the whole of this. You see the square root of 4 is a 2, and the square root of y is a y. That's a place that also many students made a mistake, and then you just have it the same way as it is, only that you alter the sign to be a negative. So for the numerator, a simplified version of it, we get it like this. And finally, we can go now to the numerator. For the numerator, what you're having is x squared plus 4xy plus 4y squared. So we want to find a way in which we can be able to factorize this expression that we have here. So we are going to look for two numbers such that the product is 4 and the sum is 4. I believe that is pretty much easy to find because that's supposed to be 2 and 2, because 2 plus 2 is 4 and 2 multiplied by 2 is 4. So definitely we pick x squared and then we add. Instead of writing 4xy, we are going to write 2xy plus 2xy. Notice that this one doesn't change the value of this part, because 2xy plus 2xy is equivalent to 4xy. It is only that we have expanded it a bit so that we are able to do some factorization. So here we pair them into two like that. We find the common term here, the common term between x squared and 2xy. That's supposed to be x. We factor it out to remain with an x there, plus once we factor out this x, we are going to remain with this 2 and this y. Therefore, we have 2 and y there. And then we have plus, what is common between here and here? It's definitely this y. This y. We factor it out. Here, if we factor out the y, what should we really get here if we factor out the y? This is supposed to give me, actually, we can be able to factor out the y, but also you'll notice that there is also a number here. There is a 2 and a 4. What's the common number between 2 and 4? It's a 2. Therefore, we can also be able to factor out 2. Therefore, what we'll factor out here is both 2 and this y to remain with this x. Therefore, we should have that x, and then we have the plus sign over there. Here we factor out 2 and y. When we factor out 1, 2, we are going to remain with 1, 2 there. And once we factor out y, we are going to remain with only 1y inside. And definitely to be able to put this together, we usually pick the first term and the other term that follows, that is x plus 2y. And then finally we pick what is there inside the brackets, which is x plus 2y, like that. And finally, what you are going to do is that you are going to pick what is there in the numerator divided by what we have in the denominator. In the numerator, we got x plus 2y. That's multiplied by x minus 2y, like that. And now for the denominator, we have gotten x plus 2y. and that is multiplied by x plus 2y, like that. So that is the part that you are getting for the numerator and the denominator. So what really remains for us is just now to just simplify this. Do you have any common terms? You have x plus 2y, we have x plus 2y, and we are going to remain with x minus 2y, x plus 2y. And that's the required solution for that. That's how really you are supposed to talk about that. But there's one thing that I really observe when I try to check the working of a number of students after they get this case and they realize that we have an x, we have an x, we have a 2y, they usually try to, I don't know how to put out -1 and try to force out this equation in a way that it will become x plus 2y. And that is not really quite doable because we already have a positive sign here. So there's no any way that you can be able to transform this one, x minus 2y, to be x plus 2y. Similarly, there's no any way that you can be able to convert this one, x plus 2y, to be x minus 2y such that you can divide them. So the last stage and step that you leave this equation at is as x minus 2y divided by x plus 2y. But one very key important thing to remember in this equation is this formula. Normally, it's usually tested. Once you see an equation of this nature, mostly they usually test this concept. And the other concept is whether you know how to factorize. You know how to factorize. So this is the first thing. And the second thing is how to factorize. If you can be able to master those two things, then you've really mastered how to work out such a question. So let's keep going and let's see the next question, how it really looks like. But I believe it's really a nice one for our practice. Amazing. I love this. We are told that the area of a sector of a circle is 550 centimeters squared. And then the question goes ahead and tells us that the sector is curved to form an open cone of radius 7 centimeters. Calculate the height of the cone. Calculate the height of the cone. So how does a sector look like? A sector of a circle, it's usually something like this. Yeah, just forgive my drawing skills, but I'll need to learn some math. So this is the sector of a circle with the area of 550 centimeters squared. I don't know who's going to teach me some maths, but it's a very wonderful skill. So we are told that this one is equivalent to 550 centimeters squared. This is just an illustration. And then we are told that this one is folded to form an open cone. A cone looks something like this. This is just a sketch, right? So this is what will be formed, and we are told that it's open and it has a radius of 7 centimeters. So I'm assuming that radius flows like this, and assume that this one is the center. And then we have this part over here. This is the one that is 7 centimeters, like that. So that is 7 centimeters. Let's now get back to the question. We are told it forms that cone. Calculate the height of the cone. Calculate the height of the cone. So if this cone is a curved, you are supposed to know how to calculate the surface area of a curved cone. How do we go about that? Curved surface area. Curved surface area. It's important to note that it is curved. Sometimes this might be interpreted to mean cross-sectional area, which is not the case for what you are doing. So this is to mean curved surface area of cone of the cone. How do you find it? We usually find it by pi RL. And you realize that this is the material that was used to create this one. And we are told that there is no any wastage. Therefore, the area, the surface area of this one is equivalent to the surface area of this one. Therefore, pi RL should be able to give you this area, that is 550 centimeter squared. Pi, we have not been given a preference, therefore we use the one that is default, 22/7. And lucky enough, the radius here is a 7, therefore it's not going to give us a lot of trouble. And then we have multiplied by L is equals to 550, like that. Divide by 7, divide by 7, we have 22L is equals to 550. What do we do to remain with L? We divide by 22, we divide by 22. Divide by 22, 1. We remain with L is equals to, oh, this is amazing. Can we divide by 11 here? If we divide by 11, we get a 2. If we divide by 11, what do we get there? 11, 5. Yeah, it should be 5. And then this 0. Finally, 50 divided by 2, that's 25 centimeters. So that's now the length. But now the question is telling us to calculate what? The height of the cone. If this is 7, we can be able to calculate this height. This is the height that you are being told to calculate. But now this L, remember L represents the length from here to here. Therefore this part is 25 centimeters. Actually, I can plot it for you here so that you can be able to visualize that quite more clearly. So that implies that this part is 25 and this part is 7, and then we are supposed to calculate this part over here. And remember, this line is running from upwards to this part, therefore what we have here is 90 degrees, like that. So to be able to get the value of height, we can try to use the association of the Pythagoras theorem, where we have h, which is here, squared, plus this 7 over here squared should be equivalent to this 25 squared. Oh, this is h squared, nothing much we can do about it for now, plus 49 is equals to 25 squared, that's gonna give you 625. And then we have h squared is equals to, we can do 625 minus 49. That's something that you can be able to work out quite easily with your calculator, and that's gonna give you 576. Finally, you find the square root, you find the square root, this is gonna give you h is equals to the square root of 576, that's gonna give you a 24. And remember to input the units, because the units were given there as centimeters, therefore you write 24 centimeters, and that is how you are really supposed to go about that. So for this particular question, what it was really getting to test you, whether you know, is that we can be able to convert a sector of a circle into a cone, because you see, if you fold this part such that this part gets to combine, or rather gets to meet these points, and you fold it in a nice way, therefore what you are going to end up getting is this particular shape that is here, and that is a cone. And what happens is that this length from here to here becomes the length from here to here, and this part over here, because you never know the next time how it's going to be asked about, this part from here to here, which is the radius, or rather the circumference of this particular part, becomes now the whole circumference that is right here, like that. So that is how it gets to transform. But now for this particular case, what you are told to find is now the height of the cone. And getting to find the height of the cone, that was testing whether you really know how to apply the Pythagoras theorem. And that's how we really get to apply that. So with that, I believe we can move on to our next question. Remember that this is a KCSE standard exam. Therefore, each and every question that you are tackling is of great importance. So we are told in this question that a clock which loses 18 seconds every hour was set to read the correct time at 8 a.m. on Monday. And then we are told determine the time in 12-hour system the clock will read on the following Saturday at 11:20 a.m. Such an amazing question. And actually, the reason that makes me to really love this question is because this is something that is quite practical. It's something that somehow it's likely to occur in a real life situation. Therefore, it's a good question to really work on. And let's really get to check on it together. We are told that this is a clock that is losing 18 seconds every hour. So the easiest way to first secure your first one mark is by getting to find the actual time difference between this date, which is 8 a.m. on Monday, to this particular date that is Saturday at 11:20 a.m. Therefore, you're going to subtract the time from Saturday back the way to Monday. And let's go ahead and do that. So we want to get the time from Saturday, or rather actually starting from Monday, the time from Monday to Saturday. So from Monday to Saturday, how many days are those? So Monday to Saturday. So we have the first day being Monday to Tuesday to Wednesday to Thursday to Friday and finally to Sunday. So those are 5 days. And now we have this other time, 8 a.m. to 11:20 a.m. How many hours are those? You see 8 to 9, 9 to 10 to 11. So those are 3 hours, 20 minutes. So the total time from Monday 8 a.m. to Saturday 11:20 a.m. is 5 days, 3 hours, 20 minutes. Let's have it here. 5 days, 3 hours, 20 minutes. That's the time that it takes to move from Monday 8 a.m. to Saturday 11:20 a.m. But you see this one, it's kind of somehow mixed up because you have days, you have hours, you have minutes, and later on here we are really dealing with seconds and hours. So it's a good idea if we can convert all these into something that is similar. For our case, to make our work easier, we can convert this one into hours. So let's convert the 5 days into hours. We know that in a day we have 24 hours, therefore we multiply that one by 24. This one, it doesn't change much because it's already in hours, therefore for that one it's really fully sorted out. And then finally we have 20 minutes. The 20 minutes, to be able to convert them to hours, what we do is that we divide by 60 like that. So we have 5 by 24, that's going to give you 120. And then we have 120 plus 3. And then we have plus 20 divided by 60, that's 1 over 3. So finally we have 120 plus 3, that's 123 and 1 over 3 hours. You see, right now it becomes a bit much awesome for us and quite easier to deal with because we now have it in terms of hours. Therefore, from Monday 8 a.m. to Saturday 11:20 a.m., the time that has really passed out is 123, 1 over 3 hours. Actually, we can convert this one to a proper fraction where we have 123 multiplied by 3. What do we get? 123 by 3, that's giving me 369 plus 1, that's 370. Over 3 hours. Let's get back to the question and see what the question is telling us. We are told that the clock is losing 18 seconds every hour. Therefore, this is 18 seconds, and it's important that you be very careful on this part. So this is 18 seconds, and the 18 seconds are being lost on each and every hour. So if it's an hour, therefore that is 1 hour. We write it there. And then the what we have in question is that we are having now 370 over 3 hours. Therefore, we have to write it here, 370 over 3 hours. This is what we want to determine. We want to determine how many seconds has been lost from Monday 8 a.m. to Saturday 11:20 a.m. Therefore, to be able to determine that, we have to do this cross multiplication over here. Therefore, that's going to give us 370 over 3 multiplied by 18, like that. So we divide by 3, 1, divide by 3, 6. This is 370 by 6. What do we get by that? That's something that is a bit much doable with a lot of ease. That's going to give us 20 seconds. Okay, so these are seconds. Can we convert this one to minutes? I believe we can be able to do that. So to be able to convert them to minutes, we divide by 60. Dividing by 60, we simply multiply by 1 over 60, and this one is going to give us 37 minutes. Oh, this is quite interesting. Can you try to picture that in your mind? That you're having a clock that is losing 18 seconds every hour, and then you'll see that now from this particular day on Monday, by the time that you are on Saturday, this clock will have lost 37 minutes. You see how the principle of accumulation is very powerful, because these small seconds, they have accumulated up to 37 minutes. Therefore, if you are not very careful, this watch might really get to mess up you a lot, because if somehow you are supposed to meet with someone at 9 a.m., therefore you are likely to meet with that person some minutes later, and actually it might make you to be a bit late for an important meeting if you are really heading for that. But the main interest for this is to be able to calculate what the question is requiring us to do. And let's get back to the question. The question is telling us, determine the time in 12-hour system the clock will read on the following Saturday. So the time that it will read on the following Saturday. So the actual time that it's supposed to read is this one, 11:20. But now this clock has lost 37 minutes. So what we do is that we minus. Again, this question is pretty good because it is also testing whether you know how to subtract time and what you do when you are in such situations like this one. Because if you look at this very keenly, you'll notice that what we have here is 20, and definitely it's not possible to do 20 minus 37 in time. So what you do is that you come here and you say this is your neighbor, and you borrow this one from this neighbor, which is from 11. So your neighbor is going to remain with 10 because you have borrowed one. But the moment that you borrow one, you remember what you have borrowed here is not just simply a 1, but it is 1 hour. And on this other side, what you're having on this particular end is minutes. Therefore, that hour, as it gets to cross over this junction over here, then it comes as minutes. And how many minutes are there in 1 hour? Definitely that's 60. Therefore, what you're going to have here is now 60 plus this 20 that you had, and that's gonna be 80. Therefore, what you're subtracting is now 80 minus 37. That's quite doable because we have 10 minus 7, that's 3, and then we remain with 7 here. 7 minus 3, that's supposed to give you a 4, and then on this other end what you are having is a 10. And remember, this is time, it's in AM, it has not yet changed to PM or any other time zone. It's 10:43 AM, and actually this is the required solution for this particular question, and that's how you are really supposed to solve about that. For me, I believe that was really an interesting one, especially getting to know how to subtract time and to be able to know whether you can be able to convert the lost seconds, whether you can be able to pile them up together. But even more importantly, this is where the trick for this particular question was, and that is whether you are supposed to take these 37 minutes and add them to the actual time, or whether you are supposed to subtract them, because you'll find a number of students getting to add these 37 minutes, and that will definitely make you to lose your mark for the answer. So for this particular case, that's how you are really supposed to handle about that. Let's open up the question that follows, and that is question 10. Oh, we are told that in the figure below, line AB is equals to 5 centimeters is a side of a triangle ABC in which BAC is equals to 120 degrees and line BC is equals to 10 centimeters. Then we are told use a pair of compasses and a ruler. This is very important. Use a pair of compasses and a ruler. Complete triangle ABC and hence measure the size of angle ABC. So this is a question that is really requiring us to do some measurements. Let me see if we can be able to get into this because it will require us to have some tools, and that is the pair of compasses and also a ruler. And it might take a while before I get to go to that software where I'm able to do that. So what I'll just get to do is to guide you step by step in a way that you'll be able to understand fully on how you are really supposed to go about this. So it's important that we go all along together. So we have part A and B here. That is line AB. This is supposed to be 5 centimeter. So this is interesting because line AB has already been plotted for you, therefore it actually makes your work easier. And then we are told that the triangle is BAC. So we have a C somewhere that we don't know, but maybe assume that C is maybe along this line, but let's not pinpoint where it is exactly for now because we have not yet checked into that. But then we are told that BAC is equals to 120 degrees. Therefore, BAC is supposed to be 120. So there's supposed to be an angle here such that this angle is 120. But there is something interesting over here which you're really supposed to follow, and check here very keenly. We are supposed to use a pair of compass and just a ruler. You're not supposed to use a protractor. So the moment that you come here and put a protractor, therefore that implies that you are going to lose the method's mark. Therefore, you should be able to work it out using compass and a ruler. But how are you really supposed to do that? You see, getting to plot 120 degrees directly using a compass and a ruler, it's almost very hard to plot it directly. So what you do is that you extend this line a little bit like this with some dotted line. And once you extend it like that, you come here with your pair of compasses, and then you create an angle of 60 degrees here. Because it's much easy to create the angle for 60 degrees. It's easy to do that. It's actually so much doable. Because normally what you usually do is that you will come, you will have your pair of compass. Let's say you have one side of it being here, and then the drawing side here, you make a mark. After you make a mark, using the same length over here, you make an arc somewhere, and also you use the same, actually that arc most likely it's supposed to lie along here because you are measuring the same length from here to here. You make a mark upwards, and also when you're here you make an arc like that, and then what you do, you join that arc at the point of intersection of those arcs. You join it with this part. What you are going to have here is 60 degrees, and definitely because this one is a straight line, automatically the angle that will be here is 120 degrees. Therefore, you must show that you first plotted these 60 degrees, because actually there's no any better way out other than that. So that will show that what really remained here is 120 degrees, so that this line is 180 degrees. But then let's go ahead and read the question. So BSC is 120 degrees. So this is a line that you don't know its length, so it just gets to extend to somewhere there. And the next statement is what is going to guide us where we are going to locate our C. We are told that BC is equals to 10 centimeters. So you are going to come here with your ruler and measure from 0 centimeters, you measure 10 centimeters upwards. So that is going to be somehow a double of AB. So if AB is from here to here, so we would say that is A bits from here to here, therefore you extend another point like that. So you'll find like AB, it's supposed to be around that point, and therefore what you'd say that this is point C, and finally you join this point C, you join it very straight with the line B. This is interesting. So what I've done here is that I've not used the pairs of compasses and a ruler. This is just an illustration on how you're supposed to go about that. And finally, you are going to come here and measure this angle that is here. And notice that you are supposed to place your compass like this, such that this tip is really, there is a line that is usually here, such that that line is really matching with this line like that. And ensure that the scale that you are measuring with, you see there's usually the inner scale and the outer scale. So the scale that you're going to use is the scale that is moving from 0, that is from the left side, the one that is moving from 0, 10, 5, 10, 15, like that. That's the scale that you're going to use, and you're supposed to measure this angle. So kindly try that later on your own and try to measure that angle. Personally, when I did it on a piece of paper, it's giving me 34.6 degrees. But normally, the answer that is given, and actually I believe this is what was used to do the marking, it's usually given as plus or minus 1. So if you get 34.5, 34.7, that's also quite accepted. So if you get 34.5, 34.6, 34.7, all this is very correct. But if you go something beyond this, either downwards or upwards, then that may not be given as a mark, because you really need to be accurate on that. So that's the structure that you're supposed to have, and that's how you are really supposed to go about that. So for your practice, it's important you know how to create 30 degrees, 60 degrees, 90 degrees without using a protractor, because it is through this that you are able to derive other angles like 45. So if you know how to construct these angles, you can always be able to construct other angles like 120 degrees, like 135 degrees, like 150 degrees, because all this is a derivation of this. For instance, 120, we get it by doing 180 minus 60. So if you know 60, you can plot 120. 135, we get it by plotting 90 and then 45, like that. For 150, you get it by doing 180 minus 30. So if you know how to plot that, you can be able to plot 150. So it's important that you also get to know about how to plot other angles like 30, 60, 90, and 45 as well. That is really quite important. For now, let's move on and keep going on these very wonderful and amazing questions that we are really having here. So here is another very wonderful, very good question for our practice. We are told that a shopkeeper bought an item from a wholesaler, and then we are told if the shopkeeper sells the item at shillings 2,470, he would make a profit of shillings 3x. The question goes ahead and tells us if the shopkeeper sells the item at shillings 23.40, he would make a loss of 2x. Determine the amount that the shopkeeper paid for the item. Let me help you bisect this question, because this is now the role of now mathematics, getting to simplify all these sentences into some mathematical terms. So if the shopkeeper sells the item at this amount, therefore that would imply that this would be the selling price of this item. If then the selling price of the item is 24.70, he would make a profit of 3x. But if the selling price, in accordance to the question, but if the selling price is 23.40, oh, the shopkeeper would make a loss. This is quite unfortunate. Would make a loss of 2x. I don't know if you guys really sympathize with the shopkeeper, but let's see where this question is leading us to. So one thing that we really need to find is the amount that the shopkeeper paid for the item. In other terms, the amount that the shopkeeper paid for the item, that is definitely the buying price. So the question is actually hiding out the word buying price, and that is what they want us to find. And I believe that we can be able to do that. But how can we really be able to do that? Let's get into it. So we are having the selling price is 24.70. You'd make a profit of 3x. But now we have to ask ourselves, how do we get the profit? Therefore, that would imply for this person to make a profit. I hope that you get this right. For this shopkeeper to make profit, then that would imply that the selling price, this is the price that he is selling that item, it is higher than the buying price. So we do the selling price minus buying price so that we can get the profit. Amazing. I believe that you do get that. We do the selling price minus the buying price so that we can get the profit. This is how we get the profit. So that would imply that what's the selling price here? The selling price here is 24.70 minus buying price. Do you know the buying price? Not really. That's actually what you are finding. The profit is 3x. Actually, do you know the profit? Not really. But we just have it as an expression, 3x. But at least we have formed something that looks quite good. Let's go ahead and see what we can do with this information. Oh, this is now the mournful part, and the part that is a bit quite not cool, making the loss, but we really have to work with this information. So that this person can make the loss, then that implies that the buying price is higher, because we do buying price minus the selling price. This is what really gives us the loss. The buying price minus the selling price, this is what gives us the loss. Therefore, that would imply that what's the buying price? We don't know actually. What about the selling price? It's 23.40. What about the loss? 2x. This is good, because we have now two different expressions, or rather equations. Here we can try to make buying price the subject of the formula. We can take it to the other side such that you're going to have buying price is equals to, if we take it to the other side, then 3x should come to the other side to have 24.70 minus 3x. For this case, we have buying price is equivalent to we pick 2340 to the other side. That's gonna give us 2340 plus 2x, like that. So this is buying price. Great, amazing. Do you see what I can see? I believe that you can see that. Amazing. Because we have buying price over here. This is an equation for buying price, and also this is an equation for the buying price, like that. So that implies that if this one is equivalent to buying price and this one is equivalent to buying price, therefore that would imply that 2470 minus 3x should be equivalent to 2340 minus 2x, or rather plus 2x. Actually, this is plus 2x. So we can try and simplify. We have 3x, taking it to the other side to have 3x plus 2x is equivalent to, what do we do it to this part? 2340 to this side, we have 2470 minus 2340, like that. 3 plus 2, that's 5x, is equivalent to 2470. This is 2470 minus 2340. This is giving me 400. Divide by 5, divide by 5. X is equivalent to 40 divided by 5. That's supposed to give me 80. So we have already found the value of x, which is 80 shillings. But the question is requiring us the amount the shopkeeper paid for the item, and that is the buying price. So we can use either of these. We have 2470 minus 3x, or this one. Which one would you like us to use between this one and this one? Personally, I don't know why. I don't like doing a lot of subtraction, therefore I would choose to go with this one where we are having addition. So buying price will be equivalent to 2340 plus 2 multiplied by 80. 80 by 2, that's 160. 160, if we add it here, it's like 2300 plus 200, which will give you shillings 2500. And actually, if you replace this x with this case where we have in subtraction, let's check it out here. What you're having here is 2340 plus 2 times 2, 2 times 80. 80 times 2, that's 160. 160 plus 340, this is 340 plus 160, that's supposed to be 500, and we have this 2000, therefore this is 2500. Yeah, that's really how it's really supposed to be. And that's the supposed solution for that, and this becomes our buying price, and that is the real required solution for that. And I believe that you are really able to follow through until this point, that you've really been able to get the solution for that, and that is the required solution. Shall we move on to the next part? That is question 12. Question 12, a very wonderful and interesting question over here, and that is we are having the following table shows the frequency distribution of marks scored by students in a mathematics test. And then we are told that the frequencies for two classes are not shown. And then we are told that the table also shows the height of each rectangular bar of a histogram drawn to represent the information on the marks scored by students. You are told calculate the missing frequencies. Calculate the missing frequencies. We have the height of the bar, and we have the marks. One thing that you're really supposed to know is how to calculate the frequency. So you see, this one is what we call a histogram. and it have got a rectangular bar. So a rectangular bar is something that looks like this. Like that. So normally, to be able to find the frequency, what we usually do is that we usually calculate the width of that bar and we multiply by the height of that bar, like that. You see, for instance, like this bar, it's 1.4. Oh, actually, there's no any bar that has really been worked out. Okay, that's all right. No worries. The height of this bar is 1.4. And then we have to calculate the width of this bar. The width of this bar, what we usually do is that we usually take the upper limit and we minus the lower limit for that particular class. So if it's for this one, to be able to get the lower limit for the lower class, it's 9.5. So this would be 9.5. The upper limit for this is 14.5. So let's actually talk it in terms of bars. Let's talk of bar 1. So bar 1 will have 14.5 minus 9.5 multiplied by 1.4. I'll actually show you a better, quicker way out on this very shortly. So 14.5 minus 9.5, what do we get here? It's supposed to be 5 times 1.4. And this is going to give me, this is like 14 times 5. This is like 7 times 10. That's like 70. And then we minus the 0 to get 7. So the frequency for this one is a 7. That's bar 1. We go to bar 2. Bar 2, what you're having here is 19.5 minus 14.5. Remember, we are taking the upper class limit for this minus the lower class limit for this, and then we multiply by the height of that bar, which is 2. This is going to give me 19.5 minus 14.5. I believe that's supposed to be 5. 5 multiplied by 2, that's gonna give me a 10. Therefore, I write a 10 there. Finally, I move on to bar 3. Bar 3, I have 29.5 minus 19.5, and this is multiplied by 1.5. Let's try to work it out together. And here you have to be a bit careful. You see, this one is a bit larger because this one is going to give you a 10 and then multiplied by 1.5, and this is going to give you 15. 15, like that. So actually, we are told to calculate the missing frequencies. I believe that we've really been able to do that. That is 7, 10, and 15. Is there anything the question requires us to do? Not really. We've been able to calculate that, and that is the required solution. So here you see that you are finding the lower limit, the upper limit, the lower limit, upper limit, lower limit, upper limit. You can always go ahead and do 4, 14 minus 10, that's 4. And you simply add 1 to get 5. And then you say 5 times 1.4 is 7. Same case with this one. You just get to do 19 minus 15, that's 4 plus 1, 5. 5 times 2, that's 10. Same case with this one. The difference here is 9 plus 1, which is 10. 10 multiplied by 1.5 is equals to 15. So that's just a quicker way out to confirm whether you really did the right thing, because as you do subtractions here, especially for the decimals, it might maybe make you to be prone to make an error, but I'm hoping that you will not do that. But that is exactly the solution for this particular question. This question, I see that it was really worth 3 marks, such that if you work out this, you get a mark. You get a mark for that. and finally a final mark for that particular part. Oh, this is amazing. We've not done any questions so far about transformation and anything that is relating to that, but I believe here is a good opportunity because there's a question that is asking something that is relating to that, and let's find out. We are told that on the following grid, line A prime, C prime is part of A prime, B prime, C prime, and then we are told triangle A prime, B prime, C prime is the image of triangle ABC after a reflection along a mirror line. How unfortunate is it that you use a mirror every day to check it yourself, but this one becomes a challenge? Uh, I hope that's not the case. So I believe that we'll be able to really bisect it so well. And let's just get into it and see how it goes. Like so, even the shapes they're usually subjected to a mirror. That's really so amazing. I don't know what they would say about themselves if they could be talking, if they had the ability to talk, and then they are given a mirror and then they are told, say something. I think that would really be so much interesting to see shapes talking. Maybe they would say, I'm an equilateral triangle, I'm a scalene. Oh, that's so wonderful. So let's get into this right away. So we are having this triangle that is ABC. It's right here. We are told it's actually this one is actually the image. No, this one is the image. Triangle A prime, B prime, C prime is the image. So this is the triangle that is lying over here. It's right here. Is the image of triangle ABC after reflection along a mirror line. So we don't have a question actually so far. Let's go ahead and see how the question is requiring us. On the same grid, draw the mirror line and hence complete angle. I hope that you can be able to see where the question is. It's right here. And complete triangle A prime, B prime, and C prime. I'm a bit curious to know if there's a question that follows after that. That is no. So that's the question for this particular part. And how many marks is that? 3 marks. We are good to go. Let's get into it. So we are supposed to complete this triangle A prime, B prime, and C prime. But unfortunately, we don't know where B is. But there's something that we know that this mirror is somewhere in between these shapes over here. So normally, what you're supposed to do, I wish I could really illustrate this in a whiteboard or rather in a board, but I'll be able to guide you step by step until you are really able to understand how you should go about it. I believe that if you follow keenly, you'll never have any challenge with questions that are involving a mirror line because this is the exact method that you use for all questions that are involving reflection, especially of this particular nature. So the first thing that you do is to connect all the given points. Let's say you have this one. So you're supposed to connect this one, A, you connect it with this A, like that. Actually, you are supposed to connect with dotted line, but for my case, because I want to try, even though it is a sketch, I want to be a bit more accurate, I'll go ahead and connect with a straight line. But for your case, just you're supposed to connect with some dotted line, and you can be able to do that. You just place a ruler here, and then you mark your pen like this. It's much easier for you. But since what I'm using now, I don't have a ruler and I need my line to be a bit more straight, I'll go ahead and connect like that. So that's what you're really supposed to do. Same case with C. Um, C, you're supposed to connect that along until you get to this point over here. So let's go ahead and do that. So this C is going to really come like that. you connect it with this C like that. And finally, you are supposed to establish a mirror line along this line. So what are you really supposed to do? So you are supposed to bisect this line, and also you bisect this line. You know, if you bisect this line into two, it's going to pass along the center of this line. Same case with this one. And something interesting is that this line, it's supposed to be actually the same line. If you bisect this line, you'll get a line that is passing across this way. Same case with this one. If you bisect this line, it's supposed to cut across this way. And it's going to pass along the same place, And actually, let's go ahead and do that. But I'm a bit not so much satisfied with my first line. Allow me to plot it because I need to really show it accurately, even though it is just a plot. Okay, so this line, it's supposed to move from here to here. So normally this line, it's supposed to come this way. Ah, great, amazing. Yeah, at least I'm a bit more satisfied because it's supposed to pass along that path. So finally, what you do is that you come here with your pair of compass. Actually, you can do this without a compass. I'll show you the trick. You come here with a pair of compass. You extend, you open it a bit, like almost as surpassing the halfway, and then you make an arc somewhere, and also you make an arc somewhere like that, and also you come at this point, you make another arc, and also here you make another arc. So once you make these arcs, you combine them, or rather you get to join them. Like for instance here, you're supposed to join this arc, you join it with this other arc like that. And for your information, do you know that this one is almost accurate? There's a way that I can be able to tell that that line is going to pass exactly there. But that is exactly what you do. Notice that this one becomes the mirror line. By so doing, you already have your mark for that. So you also need to be able to get the other marks. You see, this B, the more something is more nearer to the mirror line, that's the way that it's more nearer to the image. I hope that you realize that. You see, this C, it's so far from the image, therefore, this C, which is the symbol or rather the object, it's far from the mirror line, and because it is far from the mirror line, its image will be even more far from the mirror line in an equal measure. So if you could measure this line from here to here, it should be equivalent with this line from here to here. That's something you can tell. Even this line from here to here, it's equivalent with the line from here to here. And actually that is how I was able to know that this line is somehow quite accurate, because it's supposed to pass at the middle of this line here, from here to here. So finally, what is remaining for us is to establish where this B should be located. So in order to locate where this B should be, what you do is that you come with your pair of compass, you measure the length from here to here, and now you extend that with, you measure the length from here to here. Once you identify that length, you measure an equivalent length from this point now downwards, and you are going to notice that she's going to lie around that place, because from here to here it's around this place, and that automatically becomes your B. And I'll actually get to show you how you can be able to confirm whether that is true. Finally, you join that part with this part. So finally, the part, or rather the image that you're really supposed to get, is now this one. That is A prime. This is A prime. It is joining with this part over here, that is B prime, and B prime, it is joining with C prime, and C prime, it's connecting with now the A prime. That's the triangle that you're really supposed to get. Now, can I show you how to confirm whether you actually got the right shape? Yeah, you should go ahead and do that. So you should come here with your compass, you open it up like that. Once you open it up, you'll notice that the length from here to here, it's equivalent to the length from here to here. Same case when you are at this point, the length from here to B is equivalent with the length from here to B prime. Same case when you are here, it's the length from this mirror line to C, it's equivalent to the length from this mirror line to the C prime, which is right here. And another way to also double confirm that that is really right, once you come here where we have the object, you will notice that from the object where we have point C, the units that are from point C to B are 1, 2. 1, 2, once you count it vertically. And the same case once you come here, B to C, they are vertically 1, 2. What about horizontally? Horizontally, it's from this point. You see, this is the horizontal part of it, and we are working with B. The horizontal part of it is this one. So how many points, how many units are these? 1, 2, 3, 4. What about here? That is B to A. This is now where the image is, that is point B and point A. This is a trick that you used to employ to mark for yourself whether you actually really got it right. So how many points are there? 1, 2, 3, 4. So you'll notice that they are equivalent. All these things should really go hand in hand, and that is actually what really makes mathematics to be much juicy and something that is really so much cool and interesting, because you can see a lot of patterns that are here, and quite a lot, because even for this one you can see that these are 2 units, or rather 2 square units, 1, 2, and then this line is supposed to cut it across from one end to the other. Same case with this one, 1, 2 units, and it's supposed to cut them across together like that. And that is the trick that I actually used to know that that line is going to pass via this route over here. And let me actually show you the actual trick that I used to know that that line will pass across here. Because when you look at this part, these are how many boxes that this line is cutting across. It's cutting through across box 1, box 2, box 3, and box 4. Therefore, I just knew automatically that the middle part will be at the point between box 3 and box 4. And the part where box 3 and box 2 meet is definitely here. Therefore, that should be the center. And actually, you can repeat that for B and B prime, C and C prime. It's going to give you the same thing. And that is really quite interesting. For now, we need to move on to the other question so that we can be able to also learn another tip from it. And we have it right here. So we are told that the figure below represents a prism ABCDEFGH, and then we are told that the cross section of the prism is a trapezium. And then the question goes really ahead to tell us that BC is equals to CF. Can you locate where BC is? BC is equals to CF. Where is CF? Oh, amazing, CF. That's quite important. So this one is equivalent to that. Okay. And then we are told that AD is equals to HE. AD is equals to HE. That's pretty good. And then we are told that AB is equals to DC. AB, it's there. AB is equals to DC. Where is DC? DC is right here. Okay, that's quite good. Is equals to 2.5 centimeters. Okay. What about that? Draw a labeled net of the prism. Do we have a tied question to this? Let's check out. Not really. So this is the question that you're really supposed to deal with so that we can be able to have our full marks. Okay. So let's go ahead and plot the net of that prism. So this is the cool thing about maths, because as you also get to deal with numbers, you are also becoming a doctor in a way, because you are also getting to conduct some surgeries. But now the surgeries that you are conducting are now for shapes. So you want to conduct a surgery to this shape such that we can be able to cut it along this line, and then we cut along this line. We cut along this line. Once we cut here, check where this cursor is moving through. If you cut along this line and this line and this line, what is going to happen is that the whole of this shape that is here is going to fall on the right side. And actually, that is how you visualize these shapes, such that what you're going to get is that this one, suppose now you are going to cut across those lines like that, such that you are going to remain with this base. You remember that we've been told that this one is 5 centimeters and this one is 5 centimeters. So what you should be able to have here is, this is a sketch. Actually, we can just do it all together. Because we already know what the question is requiring us to do, we can get to utilize this space over here. Okay, we have it right there. So what we have here is we start with the base, that is 5 centimeters by 5 centimeters. So that is going to look like this. It's somehow like a square. It is indeed a square. 5 centimeter, 5 centimeter. And what's this? This is, okay, we also really need to label this shape, because this is GF. Or actually, we'll do the labeling later on. But this is basically it. You see that this part is 5 centimeters and this part is 2.5 centimeters. This is this line. You really need to visualize this. Therefore, when this flap, can I label it for you? Let me try. But I don't want to really interfere with the shape, but I want you to visualize the shape CD EF. Look at that. CDEF. CDEF. This is what we are currently plotting. CDEF, if we open it up, it's going to be a rectangle. It's going to be a rectangle with this line being 5, and then this line which is here, 2.5, it's going to be extending like that. And this other one here, it's going to extend like this. You know which line this is? This is this line over here, from here to here, because it is falling on the right side, which is 2.5. So it's going to fall like that, and this is going to be like that. And finally, there's this other part that is upper here. Again, this part here, you see this is 2 centimeters, 2 centimeters. So in short, this part will look like this. This is the best way to go about that, so that you visualize well. This part is going to be 2.5. And what about the length? The length is equivalent to 5. It's going to be 5. Therefore, if we bring it here, it's going to look like this, such that this one is again 5 centimeters, but now from here to here it's 2 centimeters. Okay, the part that is now remaining is now this other flap. You see the plane figure ABGH. Just visualize that, ABGH, ABGH. When it falls on the left side, it's going to be like this. Where you have the length from here to here, this is the length. It becomes now this part, 2.5. And this length over here, this one, I'll actually write it down here for you to see it actually much better. This one is also 2.5. and this length here is 5 centimeters. So this is the part that is connecting to this line. Therefore, we just drift this one swiftly and I will bring it there to have 2.5. Finally, what you are remaining with is now this plain figure here. For this one, I can label because I'm not going to use the diagram again so much. So remember that the part that we are having here is BC. Let me actually try to label it differently so that you don't confuse it. So the part that I'm having, this is the shape that I've really opened up such that I'll have this BC going here. And then I have GF. And then I have E. And E, I have H. From H, at this part of C, I have D and A. I'll explain this to you very shortly. And then from this B, this is the part that comes after that. Okay, that's really amazing. So let's go ahead and also open up these other shapes that are like this. If we are really to open up this flap and this other flap, you see this is BC. You see where BC is lying? It is this line. And now I want this shape now. If I could really demonstrate this in a 3D way, this shape is going to now become like this. It's going to, if it falls down, like this part that is kind of standing up, it now falls down. You're going to get something like this. I hope that you visualize that such that this is going to remain as BC, and then this part is A and D. It's like this part has been cut and this part has been cut like that, such that this one is going to fall on the left side like that. So if we are really to employ that in our part here, that part is going to be like this. Like that, such that we have AD there. Same case with this other part, the upper side here. If this part is brought down on the right side, we are going to have a shape that is extending upwards like that. And from this is point G, you don't forget, G up at the upper side of it is H, and this is a point F. The other end of it is point E. So this is actually the shape that you're really going to get. And as you do this, you see what you have been told is to draw. It is not to plot, it is to draw. Therefore, you should be able to draw it to scale. And to be able to draw it to scale, it's pretty much easier because you already have a sketch of it. And you know that this one is 5 centimeters, 5 centimeters. I believe that it's quite easy to plot a square that is 5 centimeters by 5 centimeters, and then from there you extend 2.5 centimeters, you label point E, you extend another 2 centimeters, you label point H. Same case with this part that is here. Maybe the only part that is likely to give you some little challenge is plotting this shape over here to scale, and that's what I really want to show you right now. You see, what you're really supposed to know is that from F to E, it's supposed to be 2.5 centimeters, 2.5. Also, this is 2.5, this is 2 centimeters, this is 2.5, this is 2.5, and here is 2 centimeters. So to be able to plot this part is the only one that is likely to give you a small challenge. So what you'll do, this is quite interesting. You'll take your pair of compass and then you measure 2.5 centimeters using your ruler. And once you measure that, you make an arc somewhere there. You make an arc. Same case with this one. You have one side, one tip of the compass pointing at this part where you have point G, and then you make an arc using the other part such that it is 2.5, like that. And then from there, you are really supposed to know the center between this part and this. This is 2.5. So you're going to come and measure 2.5 centimeters from here, 2.5 centimeters, which is the middle part here. And then once you measure that, you measure 2 centimeters upwards. That's where the line for this particular point should pass through, because you want to have you want to know the length from here to here. Actually, to be able to approximate quite better and exactly, we want to know the middle part. So once you have measured 2.5 centimeters here, 2.5 centimeters here, you can just draw like a small line and just know that that is really the center for that. That is the center part. And you want to have 2 centimeters here. So if you really want to have 2 centimeters here, one thing that you really need to know is that from this point to this point here, it should be equivalent to from this point to this point. And at the same time, the from this point to this point, it should be 1 centimeters and 1 centimeters, like that. So how can you be able to use that information to ensure that what you plot here is 2 centimeters? So you will come with a pair of compass and measure 2 centimeters and come with it along this line and see where it is quite fitting. And then if you see that it is exactly 2 centimeters, as you get to stretch it a bit downwards towards the center, then that's where that line is going to pass, such that it is going to pass on this arc like that. And that is going to give you your center point where you measure 1 centimeters and 1 centimeters, and that is going to give you this other part. But again, you can always get to confirm that you really did the right thing with that. But again, there's also another strategy that you can use. You can pick out this part over here. This is the shape that you want to measure, and you want it to be very accurate, like this. This is the shape that you want to create, and you already know that this part is 2.5, and this is 5 centimeters, and this is 2 centimeters, and this is 2.5 centimeters, like that. So you can come here and put a line here and put a line here. This is another way to plot this shape over here, such that this one will be 2 centimeters. If this is 2 centimeters, the centimeters that remain are 3, because the whole of this is 3. And since this one is is equivalent to this line are of equal length, then that would imply that from here to here is 1.5 and 1.5. Therefore, what you'll do is that you'll just come here and measure from here to here 1.5, and then you stretch a line upwards like that. That will be the point. And then you come here, you measure 1.5 centimeters, you stretch upwards and know that that line is going to pass via that point. And then definitely what you just require now to measure is 2.5 centimeters from here, and you make a mark where they are going to meet. I believe that really explains to you how you are really supposed to make this shape. For this others, it is quite straightforward and quite easy. Yeah, maybe this one is what required some more explanation, of which I believe you've been able to understand that. But then again, if you still have some trouble with that, I can make another separate video where I'm really explaining much deeply as I actually do it practically, so that you can be able to follow along with that. But that is exactly what you're really supposed to do in order to be able to get all these 3 marks for that particular question. Let's move on to question 15. We have it right here, and let's see the skill that you're really going to learn from this. I believe this will be a very interesting question. We are told that in the figure below, a triangle ABC, it's right here, it's good to visualize as we read. ABC is a right angle at B, so it is a right angle at this point. And we are told that AB is equals to 8 centimeters. That's pretty good. D is a point on AC. D is a point on AC such that AD is 5 centimeters. So from here to here, that's what we have, 5. And the area of triangle ABD is ABD. Where is ABD? It's this one. We are told that this area here, the shaded part, is equivalent to 10 centimeters squared. And then the question goes ahead and tells us, calculate the length of BC. Okay, that's really pretty good. But there's something that is really popping up in my mind. I don't know. How would you go about such a question where you're really supposed to calculate the length of BC with this information? Would you like to give it a thought? It's important. Well, but let's just get to check into it. So what you're really supposed to do is to first find out what we can be able to calculate with the information that we have. Is there any side or maybe something that we can be able to calculate using the information that we have? Because it is through that we'll be able to get the length of side BC, because it's not quite easy to calculate directly BC, but if we could get something extra from the information that we have, that extra element that we are going to get, it is what is going to help us to calculate the side of BC. But the fact that we have the area, we have to ask ourselves, how do we find the area of a triangle? It is a half base times height. But here we don't have the height, even though we may get the base. So the other way out to calculate the area of a triangle, it is doing a half AB sine theta. Let's see what this is going to give us, something very interesting. We are told that this one, a half AB sine theta, this is the area of this triangle. It's supposed to give us 10 centimeters. Let's go ahead and replace the values that we have to be able to get the value that we do not have. So for our case, AB will be this length, that is 5, and our B will be this length from here to here, which is 8. We don't have sine theta, we just write sine theta is equals to 10. Amazing, we can divide by 2 to get 1, divide by 2 to get 4. So we have 20 sine theta is equals to 10. What can we get from this information? We can divide by 20, divide by 20 to get sine theta is equals to a half. Oh, great. It's actually really connecting well, because that would mean theta is equivalent to antisine of a half. Can we work out the antisine of a half? I believe that's quite possible. Antisine of a half, that's gonna give me 30 degrees. Therefore, that implies that this side is 30 degrees. Therefore, that implies that if I'm to have this shape, I'm going to have it like this. This is 30 degrees, this is 90 degrees, this is 80 centimeters, and I'm supposed to find the length of BC. BC, it is this one. Let me call it height. So I ask myself, how can I be able to relate this angle, the height, and this length? Definitely, because I'm using this angle, I'm going to use SOHCAHTOA. You remember SOHCAHTOA? I ask myself, I've got the opposite of this side and adjacent, opposite and adjacent. Opposite, so I put a line where I've got O and A, O and A, O and A. Definitely this is where we get both of them being together, O and A. Therefore, we are going to use the relationship that tan theta is equals to opposite, and opposite is h, over adjacent, which is 8. Therefore, that would imply that h would be equivalent to 8 multiplied by tan theta, and tan theta here is now 60. We go ahead and work out this. 8 times tan 60, we can go ahead and feed that to our calculator directly, and that is going to give us 4.619 centimeters. So if you leave it at that, it's very okay, and that is how you are really supposed to solve about that. So the key thing that we really learn from this is that when you've got any question, it doesn't matter the kind of question it is, the first thing that you really check is the things that you can be able to get from the information that you have. Because you see, if we really tried to find the length of side BC directly, it would have given us quite a hard time. But now, since we've been able to use the information that we have to be able to get this angle that is right there, it becomes now much easier to find the length of side BC. And that is such a great and wonderful approach to go about that. And that is the required solution for that. Yeah, I believe that we can get to move on with the next question. This is question 16. We have a question tied to that. And actually, this is the last question in section A. And let's go ahead and find out what this question is requiring us to do. Okay. I'm already so much thrilled about the question even before I read it, but let's check it out together. We are told that the quadratic curve y is equals to 3x squared minus 4x passes through the point P, 1, negative 1. We are then told determine the equation of a tangent of the curve at point P, leaving the answer in the form of ax plus by is equals to c, where a, b, and c are scalars. Great, amazing. So what you're really having here is now a quadratic curve of this nature, and we are told that it is passing through the point P, 1, negative 1, and we are told to determine the equation of a tangent to the curve at point P, leaving the answer in the form of ax plus by plus c, where a, b, and c are scalars. So to be able to find the equation of this point P, we should be able to know one extra thing. And do you know what that is? It is definitely the gradient of this point P. If you can be able to get the gradient of this point, then we can be able to find its equation, because we have 1 point. And we know that to get an equation of any line, we require to have either the 2 points. If we don't have the 2 points, then we should have a gradient and either of the points. So for this particular case, we have not been given the gradient, and also we've not been given the other points. But there is one thing that we can be able to get from this, and that we can be able to get the gradient of this curve. And once we get the gradient of this curve, we are going to be able to find the gradient of this point P. So let's go ahead and try to find the gradient of this curve. We have y is equals to 3x squared minus 4x. So the gradient, we find it in terms of change in y over change in x. So what we are doing here is differentiating. I hope that you do remember how we differentiate. We multiply the power by the coefficient of x for this matter to get 3 times 2, that's gonna give us a 6. We retain that x, but we minus the power by 1. If this was 2, then that will just be 2 power 2 minus 1, which will give you 2 power 1, which doesn't make a lot of difference when we just write x like that. And finally minus, if we don't have a power here, so it's simply like 4 times 1, which is 4. And then here, this x, we are going to have it, if this was x to power 1, then we minus 1, this is x to power 0, and you see x to power 0 is just a 1, therefore 4 times 1 doesn't change much, it just remains to be just a 4. Therefore the gradient for this line, or rather the equation for this one, when it is differentiated, it becomes 6x minus 4, and this becomes now our gradient. But now remember that this gradient we can always call it for this gradient, what we have is that we know the value of x because we know that it is passing through 1, negative 1, and the value of x here is a 1, therefore we replace by 1 to get the actual gradient in terms of something that is really measurable. So we have 6 multiplied by 1, that's 6, minus 4, that's 2. Therefore, the gradient for the quadratic curve is equals to 2. That's what we have. But now we know that this quadratic curve, it is passing through the point P, 1, negative 1. And what does that tell us? If it is passing through this point P, 1, negative 1, then that implies that the gradient of that particular point, P, 1, negative 1, it's right here, P, 1, negative 1, it should be 1, it should be 2 also. But well, to be able to find the gradient of now this line, that is this line that is passing through P1, negative 1, what we really need to do, or actually what we really need to do is to have the other point, but now since we don't have, we let that to be xy, like that. Amazing. Let's go ahead and now find the equation of this line. And I hope that you do remember which line this is. Remember that this one is going to give us the equation of the tangent to the curve. It's going to give us the equation of the tangent to the curve. So let's go ahead and work out this. So what we have here is 1 minus minus 1. And what we have here is x minus 1 is equivalent to 2. So when we've got two consecutive minuses, it automatically becomes a plus. So what we have here is y plus 1 is equivalent to 2 multiplied by x minus 1, that's going to give you a 2x minus 2. So we have y is equals to 2x, and then we have minus 2, and then we take this one to the other side to have minus 1. Finally, we have y is equals to 2x minus 3. And actually, that's the required equation, and I believe that we've really been able to get that. But now you have to go back to the question, which is quite important. You are told that do that, leaving the answer in the form of ax plus by is equals to c. So you are supposed to leave it in this way. And what we have here is y is equals to 2x minus 3. So to be able to convert it in this format, what we shall need to do is that we need to have this negative 3 being on one side and then y coming to this other side, such that we are going to have negative 3 is equals to 2x. Actually, what we are doing here, once you take this negative 3 to this side, it's going to be a positive, and this 2x, it's going to remain the same way it is because we are not changing its side. And then we pick y, we take it to this other side to have minus y, and then remember that we have to start with the right hand side so that it can be able to match this equation. Therefore, we start with 2x minus y is equals to 3, and this is now the right format which matches this format that is required right here, and that is now the required solution for that, and that is question 16 for our section A for KCSE 2025 paper 1. So this video really gets to explain all the solutions for all the questions that were tested in the KCSE 2025 paper 1, that is section A. So what we'll do is that we'll have now another one that will be now explaining about, or rather getting to tackle questions that were there in section 2, which are really quite important because those questions are the questions that get to give you 10 marks in just a single question. So ensure that you also get to follow through keenly and you get to follow up with section 2 also. Don't leave it at that, and I believe that you are really able to elevate your mathematics skills, and also you are able to build your confidence by getting to follow all along, and also you are able to find how you are really supposed to tackle these questions. This is question 17 of the KCSE 2025 Mathematics Paper 1. So as we get to tackle this question, I want your mind to be very alert and to be very sharp, because I've been getting a lot of students telling me that they are really struggling with linear motion. But if you really get to follow along on this particular question, therefore you should be able to see all the other questions regarding linear motion being ridiculously very easy, because the concepts that are usually tested have been well captured in this particular question. Therefore, it's very important that you get to follow all along all the parts that have been tested. Actually, we have got 3 parts that have been tested in this question. Therefore, this is the easiest way to be able to get all these 10 marks in just one particular question. And let's actually get right into it together. We are having part 1 being here, but the first thing that we need to do is to get to the question and see the details that we've been given. We are told that the road connecting town A and town B is 160 kilometers long, and then we are told that a lorry traveling at an average speed of 45 kilometers per hour left town A for town B at 11:50 a.m. At the same time, we are told that a car traveling at an average speed of 75 kilometers per hour left town B for town A. The two vehicles met at C, a town along the road. And then we are told determine the time when the two vehicles met. I know that this might sound a bit so much information, but now it is now our work as mathematicians to be able to simplify this and to make it easy looking. And the way that we do that is to convert all this into some mathematical terms. And actually, that is what is being tested at this particular part 1. And actually, part 1 is usually there to test whether you actually understood the question. Therefore, this is a part that you can easily scoop the marks, but in the same way that it is very easy to scoop these 4 marks, it is also very easy to lose them. And the moment that you actually lose them and mess up in terms of interpreting this part, you will actually carry that mess all along, and that implies that you are going to lose all these 10 marks. Therefore, for part 1, it's important that you be able to interpret this question correctly in the right way and to be able to understand all the details that have been provided here. And the way that you are able to do that, it's usually recommended that you try to convert all this information into a pictorial form, or rather an illustration. We usually say that a picture represents a 1,000 words. Let's see whether we can be able to also carry that in mathematics. So we are told that there is a road, so we can try to imagine a road, and let's assume that our road is right here with us here. We might not be able to have a practical one, but we can be able to use the ability of imagination to be able to have a sketch on that. So we are told that there's a road connecting town A and town B. Therefore, we have somewhere that we are given as town A, and also we have somewhere that we are given as town B. This is very important because the illustration that we will get is what we are going to use in all the subsequent places. And we are told that this road that is connecting these two towns is 160 kilometers long. Therefore, we have to indicate that it is 160 kilometers long like that. What else are we are told that there is a lorry that is traveling at an average speed of 45 km per hour that left town A. Therefore, it is leaving town A, heading to that direction. And what we are having here is a lorry like that. And we are told that it is moving at a speed of 45 kilometers per hour like that. And we are told that it left town A for town B at 11:50. Therefore, it is leaving from this town as it heads towards the right direction where we are having town B. It's very important to note that. And it is leaving at 11:50. Check it how I'm really organizing this, because it's very important. Because the moment that you try to scatter out this information, it's going to give you a hard time as you try to refer to your illustration. Therefore, it's important that you have all the information about the lorry being at a particular point, and then all the other information being at their place. Let's proceed on with the question. We are told that at the same time, that is at 11:50, a car traveling at an average speed of 75 km per hour left town B for town A. You have to be very careful on this part. It is leaving town B for town A. Therefore, it is moving from this location as it heads towards the left. And this is now the car. We have to indicate that this is now the car, and the car is traveling at an average speed of 75 km per hour. I feel like that is quite logical because cars are usually faster than lorries. But let's proceed on with the question and see what the question is wanting us to calculate. So at part A, Roman 1, we are told determine the time when the two vehicles meet. The time when the two vehicles meet. So this question is just checking out whether you actually interpreted the question correctly, and actually if you did so, then we should be able to get this question correctly. But we really need to show our steps on how we get to arrive at the answer. And let's go ahead and do this. So we well know that to be able to calculate time, what you usually do is distance multiplied, or rather distance divided by now the speed. But now for this particular case, we want to see, or rather to find the time that it's going to be taken for these two vehicles to meet. Therefore, we don't just take speed, but we take the relative speed of the two vehicles. The relative speed of the two vehicles, very important. So we check the distance between these two vehicles. It is 160 km per hour. We take it as it is, and then we divide by the relative speed. And this is what you are really supposed to know in this question, that whenever the vehicles are moving at, or rather they are moving at opposite directions, like you see this is moving at an opposite direction to this one, because this one is moving towards this direction and this one towards this direction. We always add their distances to get the relative speed. Therefore, what you are going to do is that you are going to add the speed for the lorry, and we add the speed for the car. So that is going to be 45 plus 75, like that. But let's say, for instance, the lorry was moving on this direction, it was moving towards B, and also the car was maybe somewhere here, and it is also moving towards B. To get the relative speed, what we could have done is to minus, or rather to find the difference between their distances. Therefore, that would have been 75 minus 45. And this is a place that many students do usually confuse and make a mistake on this part. So ensure that you don't make mistake at any given time, but just remembering that when the vehicles are moving towards each other, you just add their distances. If they are moving at the same direction, you just put a minus. If they are moving at the same distance, at the same direction like that, you just minus the speeds. But if they are moving towards each other like this, then what you usually do is that you add. But if they are moving towards the same direction, you minus their speeds. For this particular case, we have to add their speeds. So what we get here is 160 divided by 45 plus 75. For now, there is nothing much we can do about this 160, therefore we leave it at that. But for 45 and 75, we can be able to find a simplified version of this. We have 75 plus 45. What do we get with this? This is like 50 plus 70, that's 120. We can go ahead and simplify this. We divide by 10, divide by 10, divide by 4 here, we get a 4. No, it's not really possible to divide by a 4 here, but we have 16 over 12. Their common multiple is actually a 4, so we can divide 16 by 4 to get a 4, and also 12 divided by 4, we get a 3. So what you are getting here is 4 over 3, and remember that this one is in hours. So the time taken for these vehicles to meet is 4 over 3 hours. And note that there are many students who left it at this, and this is a very huge mistake. Why? Because you have not yet calculated what is actually needed in the question. The question doesn't ask us the time taken for the vehicles to meet, but the question is asking us about the particular time. The particular time. This is the reason that I said that you really need to have your mind being so much alert as we get to tackle this question, because sometimes you get to forget these terms that are here, that it is asking the time. So therefore we have to calculate the exact time that they met. So to be able to calculate that, we should be able to convert this one into something that we can add to 11:50 a.m. And the way that we can be able to do that is to know that 4 over 3 hours is equivalent to 1 hour added to 1 over 3 hours, because 1 over 3 is equivalent to 4 over 3. But for this one, we can be able to turn it to minutes, such that we are going to have 1 hour like that, and then we have 1 over 3, we multiply by 60 to get the minutes in that. So basically what we get is 1 hour, and 60 divided by 3, that's 20. So we get 1 hour, 20 minutes. So this is what we are going to add to what we have here. That is 11:50, and that is the time that these vehicles started their journey from their respective positions, that is town A and town B. We have 1 hour and 20 minutes here. So we add them, we get a 0. 5 plus 2, we get a 70. But you well know that there is no any clock that reaches up to the 70th minute. So whenever a clock reaches the 60th minute, what happens is that it usually counts as 1 hour. Therefore, out of 70, if we take out 60, we are going to remain with 10, and then we carry forward 1 hour like that. So we are going to get 1 plus 1 plus 1, that's 3, and this is 1. If we add it directly like this, we are going to get 10 hours. But then again, we can minus 12 to get it in the 12-hour clock system, which is the one that is being used here. And let's see what you're going to get. We have 10 minutes there, and then we have to put the colons to differentiate hours and minutes. And then we have 3 minus 1, we get 1. So this is 110. And now remember that this is now in the 24-hour clock system, and it has already surpassed noon. Therefore, this one should be in PM. This is also another part that really could have confused a lot of students, and that is writing AM instead of writing PM. So there were two major tricks in this question. The first trick was the trick of being at a point where you end at this particular stage where you just get to calculate the time taken for these vehicles to meet. And the other trick was here, and that is working with time. Therefore, it's important that you be aware of that, because it's also a trick that is also likely to be repeated in the question that we'll be doing involving linear motion. For now, we need to keep things moving, and we need to get to Roman 2. In Roman 2, we are told calculate the distance in kilometers from town A to town C. So we are told to calculate the distance from here to the point where these vehicles met. So let's assume that these vehicles, this is lorry that is moving towards this direction, and the car is moving towards this direction. Let's assume that they met somewhere here, and this is point C. To be able to calculate this point C, we should be able to know the time taken from here to here, and also the the speed that this vehicle is taking to move from here to here. So the elements that we use, or rather the units that we use, are the ones that were used by the lorry, because the lorry is the one that is moving from point A towards point B. This is a very important point to use, because if you use the ones for car, you are going to get the distance from C to B. But now the distance that we are really interested in is the distance from A to C. The distance from A to C. So if we want to get the distance from A to C, we check at which vehicle is moving from A to C. You see, B is moving from B to C, therefore we are not going to use that. But now the lorry is moving from A to C, therefore these are the units that we are going to use, and we are calculating the distance. How do we get the distance? Distance, we get it by doing speed times time. But if you usually forget this, there is an easier way to remember that. You just get to say DSTV, because I know maybe some of you love movies. So when you use the acronym DSTV, you are going to get such a table like that one, and you just put a line there, and you put everything differentiated to each other, such that when you want to calculate distance, you are remaining with S times T. If you want to get T, it is D over S. If you want to get speed, it is distance over time. But that one is just to help you remember easily these short formulas. That is in case you have got difficulty in remembering them. For now, let's go ahead and apply this formula by using these units that we have here. What's the speed? The speed is 45 kilometers per hour. And what's the time taken? The time taken is now this one that we got here. This is now the time taken for these vehicles to meet, and they are meeting at point C. Therefore, the time taken for lorry to move from point A to C is basically 4/3. Can we be able to simplify this? I believe it's possible, because 45 is divisible by 3. We get divide by 3, 1, divide by 3, we get a 15. Therefore, we remain with 15 multiplied by 4. We can actually write it here so that we can be able to see that. And we get it as, this is like 30 multiplied by 2, that's 60. So we get 60, and remember the units are in kilometers, because we are dealing with speed in kilometer per hour, and also time, we've used it in hours. Therefore, the final answer becomes 60 kilometer per hour. And imagine by just doing that, you just get your 2 marks. I don't know why sometimes you people say that linear motion is a bit tricky, but you see how easy it is to solve this, especially if you are able to interpret the question correctly. But now, this final part that is here, it is the one that usually differentiates the people that are guessing and the people who are actually understanding what they are actually doing. So let's get into it and see how we are really supposed to go about that. So we've been added some more information here, and let's check into this information. We are told that the car stopped at town C for a period of 1 hour 40 minutes. That is the car. The car is the one that is actually stopping at town C for a period of 1 hour 40 minutes. What could probably be happening there? Maybe these are people who decided maybe to go for a walk a bit, or maybe they entered a restaurant, but that's not the point of much interest. The point of much interest is to be able to answer the question. Let's actually get to proceed on with what we've been told. We are told that the lorry continued with its journey at the same speed of 45 km per hour, and we are told that after the stop, the car left town C for town A and arrived at its destination at the same time as the lorry arrived at B. And then we are told, determine the average speed of the car for the journey from town C to A. I'm really hoping that you've really understood what is happening here, but let me explain to you to be able to get that clearly, so that you are able to solve the question together. So what you are told is that when these cars, or rather when these vehicles met, because now the lorry is moving towards this direction, they met at this particular point, and we saw that the distance from here to here is 60 kilometers. So when they came and met at this particular point, what happened is that this car stopped here for 1 hour 40 minutes. But now what happened to the lorry? The lorry just kept its pace, which is 45 kilometers per hour, and it just kept moving. Actually, the lorry never stopped at all. It just kept on moving from point A to point B. And now the interesting part of it is that they all arrived at their destinations at the same time. So the time that the car arrived here at point A is the same time that the lorry arrived at this point. And that really tells us something that is very important and something that we are going to apply to this question to be able to get the answer correct. And that tells us that now the time taken by the lorry to move from this point here, point C to point B, is equal to the time that this car spent here added to the time that the car is using to travel. I hope that you understood that. But if actually you've actually not understood that, I'll explain it actually more, and you'll be able to get it as we walk along this. This is what I mean. That the time that this lorry is taking to move from this point to this point will be equivalent to now the time that the car is going to use to move from this point C to point A, added to the time that this car delayed by staying here. Let's put it into some mathematical term. We are not given the time that this lorry is taken from here to here, but we can be able to get it. Why? Because we know that distance, or rather we know that time is equals to distance over speed, but we are working out the one for the lorry. Remember that, and this is really so cool, I love this. The distance that we got here, it is from here to here. Let me put it well here. Actually, I should have put it in the lower side so that you can see that clearly in a way that you won't confuse this. The distance from here to here is 60 kilometers to C. Therefore, that implies if all this was 160 kilometers, therefore that implies that the distance from here to here should be now 100, so that the whole of it can be 160 kilometers from here to here, because this one we got at 60, therefore the one that remains here is 60 kilometers. So let's just go ahead on this. And actually, let me use this color to make your mind to stay a bit alert. So the distance from there is 100 kilometers, like that, and then we have the speed. What's the speed for the lorry? The speed for the lorry is 45 kilometer per hour. Therefore, that's what you use here, 45 kilometer per hour. What do we get with this? 100 divided by 45, I believe that we can be able to divide this one by 5. Once we divide this one by 5, we get a 20. 45 divided by 5, we get a 9. What do we get in this particular part? We can actually leave it at that for now. That is 20 over 9 hours. Like that. So this is the time taken by the lorry to move from point B to point C. And actually that's also the time that is going to be taken by the car to move from point C to point A, added now to the time that this car delayed. Therefore, to be able to get the time used by car in traveling, you'll see how this question is very simple, very shortly. Let me show you. So to get the time used by car in traveling, what you're going to do is that you're going to take the total time taken in the whole journey, that is 20 over 9. That is the whole journey from when these cars met. You minus now the time that now the car stopped, and the car stopped for 1 hour 40 minutes. 1 hour 40 minutes. Oh, how should we minus this? Let's get into it. So we have 20 over 9. minus, you see that this one is 1 hour 40 minutes. 1 hour 40 minutes is equivalent to 1 hour 40 over 60 hours, because we want to convert these 40 minutes into hours so that we can be able to do some good minus here. So we can divide by 10, divide by 10, divide by 2, we get a 2, divide by 2, we get a 3. So this is 1, 2 over 3. So there's nothing much that we can do about 20 over 9, therefore we just put it at that 20 over 9. What about this other part? Then we have minus. For this one, we can be able to convert it into a part where we have only the numerator and denominator without having the whole number. So we have 3 multiplied by 1, we get a 3 plus 2. That's going to give you a 5 over 3 like that. So we are supposed to minus this. So you have 20 over 9 minus 5 over 3. Here we can use the concept of BODMAS, or rather the concept of LCM. We have the LCM of 9 and 3 being 9. So we have 9 divided by 9. That's going to give you a 1 multiplied by 20. You get a 20 minus. You have 9 divided by 3. You get a 3. 3 multiplied by 5. You get a 15. So basically what you're getting here is 20 minus 15. That's going to give you 5 over 9. Remember, this is hours. Now this is the time that is spent by the car in traveling. So the time is 5 over 9. And do you know the speed of the car? The speed of the car, we have it right here, 75 kilometers per hour. We really need to check that, the speed of the car. Yeah, we are told that the car is traveling at an average speed of 75 kilometers per hour. 75 kilometers per hour. So we need to note it there, 75 kilometers per hour. Is there any other information that we need? We need the distance. And the distance that is actually being moved here, the distance that this car is moving, where do we have it? The distance that this car is moving is this one. Because now the car is at point C and she's moving towards A, therefore it's supposed to cover 60 kilometers per hour. And remember this one, the speed of this car is the initial one. This is the initial speed. Let's get back to the question and see what the question wants us to find. The question is telling us that after being given all that information, the question goes ahead and tells us, determine the average speed of the car for the journey from town C to town A. Oh, great. This is really wonderful. So we are being asked about now the new speed. You have to really indicate that now you are working out the new speed. New speed. And already you can tell that for this vehicle to be able to get to point now A, it have to move at a higher speed. But let's see whether that is so. So to get the new speed, definitely what we have to know is how to find speed, and we find speed by doing distance over time. And we already got that the distance between now point C to A is 60 kilometers per hour. And now the time that is now taken by that vehicle in traveling is 5 over 9. So we are doing 60 divided by 5 over 9. How should we go about this? We have 60. It is divided by 5 over 9. Whenever you've got a division sign, we usually change it to a multiplication, and then we invert the fraction that is there. Therefore, if this one was 5 over 9, you invert it and you get 5 there. Therefore, you're going to have 60 multiplied by 9 over 5. we go ahead and simplify this. Divide by 5 1, divide by 5, you get a 12, and then we have 12 multiplied by 9. That's gonna give you 108 kilometers, like that. And actually that is 108 kilometer per hour, and that is the average speed that the car is using from point C to A, and that's how exactly you are supposed to go about this question, and that is the required solution for that. So if you are really able to follow all these steps that we've used and you follow them accurately, then you should be able to get these questions correctly. But the most important thing is to be able to understand, especially for this particular part, how to be able to interpret the question correctly. So even as you make an illustration, it's always important that you get back to the question and see that the illustration that you made is matching with the details that you have in the question, but also even beyond that, to be able to get into the particular thing that the question is asking. Because if it's asking about time, you may be tempted to leave, you are working at this point, and then you say, I just got to the part that the question was requiring me to calculate. But that is not exactly what the question was asking you. It was asking you about the particular time. And for this other one, it's just building on what has been there before and getting to apply that knowledge as well. Therefore, I'm really hoping that if you get other questions regarding linear motion, you'll not be able to really find them being easy, but you'll be able to just walk through them easily. And actually, we'll continue sharing some more questions that do revolve around linear motion. Therefore, it's important that you keep following this channel and ensure that you've really subscribed to ensure that you don't miss out on any single tutorial that we get to share. And also remember that KCSE Mathematics have produced some very wonderful, great books for KCSE. You can be able to get the book that is right on your screen to have it delivered from any part of the country. And actually, almost 80% of the KCSE that was done was derived from part of the questions that were there. There are some exact questions that were really asked in KCSE that really matches with the questions that we've given there. Therefore, it's important that you ensure that you have that book as well to help you in your revision. So the next video is coming up, so you can just get to click on your screen on those in either of the two sections that are there to continue following up with the tutorials that are here. Let's get to question 18 of the KCSE 2025 Mathematics Paper 1. It is such a contrast the way that this question looks like a monster as well as a scarecrow. But once you look at it very closely, you're going to realize that it is just a simple pyramid that is resting on top of a simple structure that is right there. And that makes it to be really a very wonderful architectural design. And actually, before it gets to scare you away, let me just go ahead and simplify it for you. So we are given this figure that we are told that it is figure VABCDEFGH. It is important to visualize that. That is figure V, A, B, and then we have C, D, E, F, G, H. Yeah, like that. So that is simply pointing out the full figure that we have there. And we are told that it is a solid that is consisting of a right pyramid. So we have a right pyramid that is right there. It's important to note that it is a right pyramid because we are going to apply that. And we are told that it is mounted on a rectangular block. And then we are told that the right pyramid and the rectangular block have an identical square base of length 6 centimeters. I believe we can be able to see that the base for this one, for this solid figure here, it is simply 6 centimeter, which is a square. And then you're told that the height of the rectangular block is 10 centimeters. So we have the height here being 10 centimeters, and then we are told that VA and a VB and a VC and a VD is all 5 centimeters. Therefore, that implies also this one is 5 centimeters, 5 centimeters, 5 centimeters. And let's go ahead and see what we've been asked. We've been asked to find the volume. And do we have a second part? Definitely we should have a second part because this is a section B question, and we have it right here with us. We'll get to part B once we are done with part A. And actually part B seems to be much juicy and to be much interesting, but we'll get to that very shortly. Let's first get to part A. Part A, we are told calculate the volume of the solid. Actually, this is a very wonderful question. It's actually getting to touch on finding the area of figures and also some part of 3D, that is the three-dimensional geometry, especially on part B. Therefore, that would give you a good practice on those two particular areas. So to be able to calculate the volume of the solid, we should be able to identify the solids that are here and how we can be able to find their volume. You see, it's very difficult to find like the whole shape, the volume of the whole shape, but the way that we can be able to find it much easily is to be able to identify the first shape that is here, which is a right pyramid, and then we add the volume for the rectangular block that remains. Therefore, we are going to say that the volume of the solid, we are going to get it by doing the volume of the solid, or rather of the rectangular block. And then once we get the volume of the rectangular block, we add that one to now the volume of now these other upper parts, this part that we have here. And I believe that you can be able to visualize that. That is the volume for the right pyramid. Let's write it down here, the volume for the pyramid. For this rectangular block, that is not likely to give you a lot of trouble because this one is like a cuboid. You see that this part that is here, that is part A, B, C, D, going downwards to F, E, H, G. This one is a cuboid. And the way that we find the volume of a cuboid is that we usually do length multiplied by the width and then multiplied by the height. For this case, we have the length is 6, width is 6, and then the height is 10. Therefore, we just go ahead and simply apply that. That is 6 multiplied by 6 multiplied by now the height. Do we have the height? The height we have it as 10. We write it down like that, and then we add the volume of the pyramid. How do we get the volume of the pyramid? To get the volume of the pyramid, you see the way it appears. This is the shape of this pyramid, that is pyramid ABCDV, the way it is like that. The way that we get that is that we do a third multiplied by the base area. And what's our base area? The base area is now this part that is here. We need to find the area of this particular part, that is part A, B, C, D. So it is plus a third base area. Let's first try to work out the part for the base area. See, base area, we get it via this shape that we have here. Actually, we can work it out here so that we can be able to visualize clearly what we are really working on. But essentially, when you have your paper, it's important that you just work it where you are doing the other workings. The reason that I chose to work it here is so that you can be able to visualize clearly on what you are really discussing about. So to be able to get the base area for this, let's check out on really how we are really supposed to do. So we have this figure ABCD, and you see we were told that this one is a square. So to be able to find the surface area of a square, normally what we usually do is that we take the length multiplied by the width. So for this particular case, you see the length here, if this part is 6 centimeters, therefore that would imply that also this part is 6 centimeters. And if this part is 6 centimeters, Also this part is 6 centimeters, like that. So what you're supposed to do here is that the base area is a third, or rather the base area is 6 multiplied by 6. And remember here, since we are finding the volume, we have to multiply the result that we get here with the height. But this is not just a height, but the perpendicular height. Therefore, we must be able to find the particular perpendicular height for this shape that we have here. So we are finding the perpendicular height here. You might be confused and tend to take this one as the height. If you take this one as the height, that is really totally incorrect. Why? Because that is not the perpendicular height. Yes, it is a height for the slant height, but it is not the perpendicular height. To get the perpendicular height, we are going to put a bisection here, like that is running from A to C, and then from there we should be able now to get a line that is running from here now to somewhere at the center of this. Now the part that we are interested in is now the part V to this point. We can actually let this one to be point O, since it's actually at the middle of these lines that do intersect here. So we are finding the length for VO. And what do we have so far? It will require us to do some bit of calculations here, and this is what makes it to be worth the many marks, that is 4 marks, because now after we've been able to find this, it will just be a matter of just getting to replace that with the perpendicular height, and then we'll be able to get the final answer. But for now, let's just go ahead and do this. So we have this shape here. We are going to abstract it out. So to be able to get the length from here to here, we realize if this is a square, therefore that implies that this one is 90 degrees. So we can be able to get the length AC. So AC would be equivalent to this part 6 squared plus 6 squared, and then we find the square root of that. Therefore we have 6 squared plus 6 squared, and then we find the square root of that. Therefore that would mean that the square root that we are finding is the square root of 36 plus 36, and this is going to give you the square root of 72. The square root of 72, it's going to give us what we have. You see, 72 is equivalent to 6 multiplied by 6 multiplied by 2. Therefore, this is the same as the square root of 6 multiplied by the square root of 6 multiplied by the square root of 2. You see the square root of 6 multiplied by 6, that is going to give you 6, and then you have root 2. But now the length that we want to get is the length from here to here. Therefore, we have to first get the half length, that is the length from here to here. And how do we do that? We are going to take this 6 root 2, and then we divide by 2. Therefore, it will be true to say that OC is equivalent to 6 root 2, we divide by 2, and that is going to give you 3 root 2, like that. Therefore, the length from here to here is 3 root 2, like that. Now to be able to get this perpendicular height, notice that this one is 90 degrees, that is angle VOC. Therefore, to get the perpendicular height, we take this one, hypotenuse. Remember, we are finding the value for VO. That will be equivalent to this length, the slant height 5 squared, and then we minus the square of 3 root 2. We write it down 3 root 2, and then we square that, and we find the square root of all these. This is going to give us 25 minus 3 root 2 squared. That's supposed to give you 9 times 2, that's 18. So this is going to give you root 7. Therefore, the perpendicular height here is root 7, like that, root 7. So we can go ahead and replace that in our equation here. This one was just to explain to you that you're supposed to get the base area first. And since we've been able to do that, we just simply go ahead and substitute now the perpendicular height. We got it as this one, root 7. And then we have a plus 6 times 6 times 10. like that. So we can go ahead and work out this. We have 6 times 6 times 10. This is 36 times 10, that's 360. And then we have a plus, a third multiplied by 6, that's divide by 1, and divide by 3, we get a 1, divide by 3, we get a 2. So here we get 6 times 2, which is 12. 12 times root 7. Root 7 is equivalent to 2.646. So actually we can go ahead and find the final answer for this. When we multiply all this, that is 2 by 6 by root 7. Let's find out what we are going to get with that, because it's important that we have it. This is going to give us 31.749. 31.749. So basically what you are going to do is to do now 360 plus that. Let's see what we get. That's going to give us 391.749. So we can actually leave this one to 3 significant figures to have 391.7, and this is in centimeter cubed, since this one is in volume. You see, volume is in cubic units, and the units that we are using for this particular question is in centimeter, therefore we have to leave it in centimeter cubed. If you forget and write centimeter squared, you are likely to lose the final answer mark. Therefore it's very important that you ensure that you do indicate the required unit for that particular question. So that is it, and that is how you are really supposed to go about that. You see, just doing these simple calculations, you are able to get all the full marks, which is 4 marks, by just doing these simple and quick calculations. But the most important thing is to ensure that you use the right formulas, and also you work out the calculations correctly, and also you use the right measurements as you do that. Those are the key things to check in as you get to work out the volume for that. So let's get to part B. Part B actually seems to be a bit much interesting. We are told that the solid is cut into two identical halves along the plane of symmetry VAF HCF, and then we are told calculate the surface area of one of the pieces. Calculate the surface area of one of the pieces. This is amazing. So just someone created the shape and decided to cut it into two parts, into two identical parts. That must have been really so much amazing. But what you're really supposed to do is now to get into the calculation part of it, but not to really wonder why the person did that. Let's try to master out this. This is VAF HCF, VAF HCF, VAF, VAF, VAF HCF. I believe that I got that correctly. VAF, it's actually HCF or HCV. It's supposed to be HCV, yeah, HCV. That's the part that it was really cut into HCV, like that. VAF, HCV, so that we are able to visualize from this particular shape. Let's check where that figure is. VAF. So we've been told that it is cut into VAF like this, and then HCF. So VAF H, so it has been cut along this line like that, and then it is coming upwards. Oops, I need to run my line well like that. Great. And then HC, and then we have HCV, yeah, HCV like this. So basically this shape is running from these particular areas VAF, VAF, So I'm drawing this so that you can be able to visualize this completely. VAF. So this is the shape, this is the way that she has been cut. So it has actually been cut into VAF and then H and then C and then V, like that. I believe that you can be able to visualize that. So what you are told is that you are told to calculate the surface area of one of the pieces, the surface area of one of the pieces. And the reason that they get to tell you that you calculate the surface area of one of the pieces is because it doesn't matter whether you take the front side of the other part that remains on the other end, because all along, if you take either of the cases, you should be able to get one similar answer because they are identical. They are identical. The fact that they are identical implies that if you work out the area of any one of them, then you should be able to get your answer correctly for that. Um, I would like to work out in a place that you'll really be able to see the working, and you'll be able to also compare with the shape directly. So therefore, that's why I really want to have, or rather to find a way of working it out here. But mostly when you find such a question, you don't get to get scared right away without getting into the particulars of the question, because there are sometimes that you see a question and you see the shape that is there and you see like, oh, this is kind of like a monster, but once you look at it very closely, that's then when you realize that it is actually something that you've dealt with before, only that they have been packed together like this. So let's go ahead and try to work it out together and see what we are really supposed to do with that. So basically, if we are really supposed to calculate the surface area of this, you're going to realize that there are many shapes that are actually getting to come along with it. So the best way to go about this is to identify the parts that are there. And once you've really been able to identify the shapes and the parts that are there, then you'll really be able to work out them, to work out those particular shapes. Like for instance, what I want us to do is to pick up these part that is here. So we are going to pick up the front side. So that implies that we will work out the surface area for this one, and also for this shape that is here. And also after we are done with that one, we also have some shapes that are here downwards, but I'll show you as we proceed on. But by you getting to follow all along as we work out these, you'll be able to identify the simplest way to go about that, and also in a way that you will avoid making errors and also forgetting some shapes. So what I want us to do is that we are going to start with the shapes that are triangular in shape. So we start with triangles. We identify the triangles that are there in the front side, are in the front side when this shape is cut along this end. You see, when it has been cut along this part, it is cut all along upwards like that. So the first triangle that we are really able to identify from this is this particular triangle, and that is triangle VAB. That's the first triangle that we identify. So you must be able to calculate the value of that triangle VAB. The other one is this triangle that is right here, and that is triangle VBC. I believe you can be able to visualize that VBC. And then we have the triangle. You see, the part that we are taking is this part has been cut, therefore we take this surface VBC, and now we'll also have this other part that is here, and that is this now triangle. This is now actually one of the most forgotten shapes, which might make you to lose the marks if you actually forget it. And this is angle VAC. Just check it where it is, angle VAC. Can you see that VAC? VAC. It is actually cutting across this part like that, but we have to remember that VAC. But you see again, when that is cut, there's also this other part here. This is another triangle that is there. This that lies at the base of this particular case, and that is this VGH, or rather actually FGH. We have to write it down, FGH. So if we can be able to work out the areas for these triangles, then we can also check out on the other shapes that are there as well. But for now, let's start with this one, which is quite walkover for us, and let me try and guide you as we work out on this. So if we are supposed to work on triangle VAB, we are really supposed to know what is the base for this triangle, and also what is the height for this particular triangle. And that will just get to sort out everything, because that is exactly what we are really supposed to know to be able to work out the surface area for this particular triangle. Well, we know that we are supposed to use a half multiplied by, now what we are working is for VAB, a half multiplied by the base. Do we have the base? We have the base as 6. What about the height? The height, we must be able to calculate it. Let's take out this triangle out, so that you can be able to visualize it much clearly. So this triangle looks something like this. Actually, let me put it in a way that you'll be able to associate that, because this length here is equivalent to this one, and this is from here to here, that is supposed to be 5. And now from here to here, that's supposed to be 6. But because I want to get this height, I'm going to divide it into 2, such that I have 3 centimeters and 3 centimeters, and I want to get this height. Therefore, this height, we use the Pythagoras theorem. We find the square root of 5 squared minus 3 squared, like that. This is going to give me the square root of 25 minus 9. 25 minus 9, that's supposed to give me 16. The square root for that is 4. Therefore, what you're supposed to multiply here by is a 4, like that. That is done for VAB. Let's go to VBC. VBC, how are we really supposed to go about that? You realize that VBC is right here, and actually VBC is similar to VAB. Therefore, working out for VBC is simply taking up this one. It's going to give you the same thing because these triangles are quite identical. Therefore, we can actually go ahead and write that for VBC, just to show the examiner that you worked out for VBC as well, you put a half multiplied by 6 multiplied by 4, like that. Then we move on to VAC. VAC, where is VAC? VAC is here. For VAC, you need to be a bit careful as you work out this, because this one is somehow hidden, and we are finding a way of getting to unhide that. Okay, let's get to it. That is VAC. I believe that you can be able to locate where it is, because the first thing that you're really supposed to do or to know is where it is, and that is VAC. It is tiny like this. Why we able to get the value for this part? Yeah, this part is 3 root 2. This part is 3 root 2. And we want to get for VAC. So that implies that you are supposed to take a half multiplied by the base. Remember, the base is what is running from this point A to point C. I believe that we had worked out that, and we had gotten that the value from here to here, we had gotten it as 6 root 2. But we can always confirm, because we get the length from here to here as the square root of 6 squared plus 6 squared, and we say that this one is equivalent to the root of 72, and 72 is equivalent to the root of 6 squared multiplied by the root of 3. Because this is 36, it's actually the root of 2, because this is 36 multiplied by 2, that's 72, and the square root of 6 squared, that's 6 root 2. Therefore, the distance from here to here is 6 root 2. The only thing that we might now want to get is now the distance from here to here, which is now the perpendicular height, the height for that triangle. And the way that we are able to get that, and actually we had gotten that as root 7, so we can just simply go ahead and write it root 7 instead of getting to calculate again. But in case we had forgotten, the way that we are able to get that is that we take this 5 squared, which is right here. This is a 5. So we take it as 5 squared, and then we minus the half length from here to here, which is 3 root 2, and then we square this one, and then we find the square root of this. This one should give you root 7, like that. So finally, we add the final triangle, and that is FGH. FGH, this is an interesting one because it lies at this point here. This is FGH. Okay, let's find out how we are really supposed to work out this FGH. So we are supposed to know that this one will be now the base for that triangle, but now the height will be this one. This one will be the height. So we have a half multiplied by the length from here to here. We had gotten that already from here to here. That is 6 root 2. That's why you really need to remember these sides like that. That is 6 root 2. So I believe now to be able to get the distance from here to here, it is halfway from here to here. So basically, you see, since this one is a square, and I really hope that you do really visualize that. If this one is a square, then that would imply that the length from here to here is also the same length from here to here, which is 6 root 2. Therefore, the length that is running up to halfway is the half of 6 root 2. Therefore, 6 root 2 divided by 2, that is going to give us the length from here to here, and that is going to be given as 3 root 2. Remember, the question that we are working on, or rather the part that we are working on, is a part that is giving us some 6 marks. So by working out these triangles, I believe that we should have about 3 or 4 marks thereabout. Let's go ahead and simplify this. We have a half multiplied by 6 multiplied by 4. 2, we divide by 2, there we get a 1, divide by 2, we get a 3. So therefore what you're getting here is a 12 plus 12 there, and then plus this one we can work out with the calculator. Divide by 2, 1, here we get a 3. So we have 3 root 2 multiplied by root 7. That's really supposed to give you something to do with 11.22. You can actually take it as large number as you wish. So it's 11.225655, and then we add for this particular final case here, divide by 2, 1, divide by 2, we get 3. So we have 3 root 2 multiplied by 3 root 2. This is going to give me 3 times 3, that's 9. 9 multiplied by 2, that's 18. Actually, it should give you a perfect number like that. So basically what we are having here is now 12 plus 12 plus 11 plus 18. You see 18 plus 12, that's supposed to give me 30. 30 plus 12, that's supposed to give me 42. 42 plus 11, that's supposed to give me 53. And then that will be followed by now the decimal places that we have here, which is now 0.22. For now, you can actually go ahead and round off here, 6. So basically what we get, we can put it into 4 significant figures to have 53.23, and I remember that this one is in centimeters squared. But before you go ahead and jump into the next question, remember that we are not done, because the surface area that we've really found is the surface area of the figures that are triangular in shape. Therefore, in the shape that we have, which is the shape that you are given, which is VAFHCN, we should also check whether there are other shapes that are not triangular in shape, and definitely we have them right here. And that's now the final part. And now once we are able to work out that, then we should be able to get all the full marks for this question. And actually that's the part I feel like it's actually the easiest part to work out. But the fact that it is easy doesn't imply that it is automatically simple. And the reason that that is like that, it's because if you're not so much careful, you are likely to miss out on some shapes that are here. So the first shape that is here, and this is now the rectangles. So we have to put rectangles. Actually, as you do it in your exam, it's important to list out the shapes that are there to be able to guide the examiners through your working, and that makes his or her work much easier. So for the rectangles that we have the first rectangle as this one, that is ABGF. This one, let me shape it for you. ABGF. So we write it down, ABGF. Can you be able to spot any other rectangle? Yeah, definitely, I believe you can. And that is this triangle that is BGHC. So we write BGHC, that one. And then finally, we have got another rectangle. So we have this one done already. Finally, the other rectangle is the one that is going to cut across this part. I'm hoping that you'll be able to see this. Check at how my cursor is going to run. Check at this shape. This is C, A, F, H, C. Do you see that rectangle? Or should I go one more time? This is C, A, F, HC, that is the rectangle, because this shape is cut diagonally into two pieces. Therefore, we have to add that shape, that is CAFHC. And actually, this is now the simplest part to work out. Why? Because it doesn't involve a lot of calculation. For instance, you see ABGF, this is ABGF. We simply work out the surface area for this as length multiplied by the height for that, or rather the length multiplied by the width, and that is simply 6 multiplied by 10, because the length from here to here is 10. So that is 6 times 10, and then we add. Similarly, for this one, that is BGHC, it is also 6 multiplied by 10. We write it there. And finally, this is pretty much easy, because now the final one is this one, that is C, A, F, H, C. And the way that we do that is also length multiplied by the width. The length, we have it right here, it is 10. And what did we get as the value from here to here? The value from here to here, I believe that we got that already as 6 root 2. So we don't have to work it out again. So what we're having here is a 60, and then plus 60, and then this one we can work out with a calculator. This is 60 root 2. What is 60 root 2? 60 root 2, it's supposed to give me this is 10 times 6. Yeah. So that's supposed to give me 84.85. If you like it, you can go some extra decimal places like that, and it's going to give you that. So finally we have, this is 60 plus 60, that's 120. 120 plus 84, That's supposed to give us 204. This one, you can go ahead and actually put it into 2 decimal places. That's going to give you 85, and this is in centimeters squared. So we have rectangle and triangles. So the final job that now remains is now to calculate the total surface area. And now we get the total surface area for that. And now this is now the total. It will be now equivalent to triangle plus now the rectangles. And that will be equivalent to 53.23. You add it to 204.85. So for that one, you can actually go ahead and use your calculator for that. Let me see what we get with this. This is 53.23, and then we are adding to 204.85. This is giving me 258.08. This is in centimeters squared. It's always important that you get back to the question to see if you are told to put that one is in particular decimal places. We are told the solid is cut into that, and then calculate the surface area of one of the pieces. And I believe that we've been able to do that. We've not been told to put the final answer in particular format, example like 3 decimal places of 4 or 1 or 2, so we can leave it safely at that, and that is quite satisfactory. If you are able to do that and you follow the steps keenly, then you should be able to get all your 6 marks for this particular section. And this is part B, only that I wanted to work it out here so that you can be able to visualize well how the shape looks like, and that is the exact required solution. I know that at first it looked a bit quite hard and a bit quite scaring, but you see, once we are able to bisect it and once we are able to look at it very keenly, it becomes even much easier and even more fun to work out on such. So you can keep at it and ensure that you keep following and keep checking on the questions that are posted here for your revision, and also to continue empowering your mathematics ability, and also to continue improving on your critical and creative thinking. This is question 19 of the KCSE 2025 Mathematics Paper 1. You see, at first sight, this question might look a bit so much mysterious, but after getting to solve it, you'll start feeling like that hero and that superstar of a movie that you like, or even like a magician. But the interesting part is that this question does not require any magic to work out. It just requires you to understand the concepts that I'm going to show you in a short while. And actually, this is one of the best questions to practice with in this topic of equations of straight lines, because it gets to cover a lot of things. There are things to do with parallel lines in this question, perpendicular lines. There are things to do with gradients of line. There are things to do with intersections. There are things to do with equations and many other things along this question, which makes it a very wonderful question because you are going to cover a lot of things in just one single question. And let's actually get right into it. We are told that two lines, that is L1 and L2, are parallel, and then the question goes ahead and tells us that a line L3 is perpendicular to both lines L1 and L2. And then in part A, Roman 1, we are asked to find out, rather the question goes ahead and reads as follows. That is, line L1 passes through points A, -36, and B, 39. And then we are told find the gradient of line L1. This is exactly what you are going to start with. You see the way that it is a very spicy and a very wonderful question. We are supposed to find the gradient of line 1. So the first thing that you really need to understand is how to find the gradient of a line. And the way that you find the gradient of a line is that you find the change in y divided by the change in x. But now the point that we have in our question are negative 3, 6. You see, this is the first element in this bracket usually represents x1 and the other one represents y1. And then for this other part, we have our second x there and our second y right there. So the first element is representing x and the other one a y. So the change in y here, therefore, that will be now the new y, which is 9 for this particular case, we minus the previous y, which is now 6. And then we divide that with now the change in x. How do we find the change in x? We find the change in x by taking the new x. For this particular case, it is these 3. And you see that they are really matching up together. And then we minus the 3 that we had previously, which is now negative 3. And this is a part that requires us to be a bit alert, because you see at this particular part we are having 3 minus negative 3. And this is a part that many students usually make an error, because they usually forget and go ahead and write 3 minus 3. And actually that is going to make you get a 0 here, and you are going to be a bit stuck. And the moment that you are stuck at this particular part A, you are going to remain stuck all along, because the subsequent questions require us to use the answer that we get here. For now, since we've really been able to put this accurately as it should be, let's go ahead and simplify what we have on our screen. So we are having 9 minus 6, that's gonna give us a 3. And here, what do we have? What we are really having here is 3 minus minus 3. Remember the law of integers in Form 1, that is whenever you've got consecutive minuses, usually convert that one to be a positive sign. Therefore, this becomes 3 plus 3, and that is going to give you a 6 like that. Let's go ahead and simplify this. We have 3 divided by 6. We can divide here by 3 to get 1. We can divide 6 by 3 to get a 2. And finally, we get our answer as 2. And that is exactly what is the value of gradient of line L1, which is this one that is right there. With that, we can appreciate ourselves a little bit and move on to part B, or rather the second part, which is Roman 2. Roman 2, we are told that line L2, now something new has been introduced here, and that is line L2. Let's see what is about line L2. So we are told that line L2 intersects the x-axis at point C, negative 5, 0. Determine the equation of L2 in the form of y is equals to mx plus c. You see, to be able to find the equation of a line, we should at least be able to get two things. Either the 2 points of a line. If we are unable to have the 2 points of a line there, then we should be able to have at least one side, 1 point of that line together with its gradient. But for this particular case, we are only given 1 point of this line, and this is negative 5, 0. This is negative 5, 0. We don't have any other point of this line L2, but we know that whenever we've not been given the value of something, we can always assume it to be a value that is unknown. For instance, for our case, we let it to be xy. So this is the second point of our line L2. The first one is this one, negative 5, 0, which we've been given, and then the second one is xy, which we have not been given. So what's the other thing that you're really supposed to have? The other thing that you're really supposed to know is the gradient of this line L2. But unfortunately, we've not been given. But the good thing is that we can be able to get that. And how can we be able to get that? By finding the relationship between L1 and L2. If these guys are friends, then they can be able to share something in common. Let's get back to the question and see what they share in common. What we are told from the initial starting point of this question, we are told that two lines L1 and L2 are parallel. This is very important. They are parallel. So what you're really supposed to know is that parallel lines usually share a common gradient. Therefore, that implies that if the gradient of this line L1 is a half, then that would also imply that the gradient of this line, which is L2, is also a half. Therefore, we are going to go ahead and put a half here as the gradient for this line. So therefore, we can go ahead and find the change in y divided by change in x. So the change in y, that will be y minus 0, and then we are dividing that with now the change in x. The change in x is x minus negative 5. And we well know that this one is equivalent to now the gradient. The gradient is a half. Well, you see this one, there's nothing much you can be able to do about it. Therefore, this one can just rest it as just a y. And for the lower case, what we have is the denominator is equivalent to x. Whenever you've got two consecutive minuses, that automatically changes to be an addition sign. Therefore, we have x plus 5 is equals to a half. Well, this question is not really in good order. Therefore, we need to do some cross multiplication here, such that you are going to have y multiplied by 2. That's going to give you a 2y. And then on the right side, you get 1 multiplied by x plus 5. It's going to remain as it is, that is x plus 5. Finally, you see what we are having here is 2y is equals to x plus 5. But what does the question tells us? You see the question is telling us determine the equation of L2 in the form of y is equals to mx plus c. You see here where we have y, there should be any coefficient to that. Therefore, to remain with only a y, we divide by 2 everywhere. Remember that all these are your kids. Whatever you do to the first kid, you do to the second one and third one. So you divide by 2 all over the other numbers as well. So what you're going to remain here is that these 2 divided by 2, you remain with y is equivalent to x over 2, which you can write it as a half x. And then you have plus, this is 5 over 2, you can simply write it like that. And essentially, this is the final answer that you get, and that is now the equation of L2. You see, you already have your 2 marks here, and you already have your 2 marks here. But still, we have not yet completed this journey, because we still have some 6 more marks and also some more concepts that we should be able to cover in this part B. And let's just get right into it and see what it is requiring us to do. We have part B. We are told line L3 intersects line L1 and L2 at points A, negative 3, 6, and P respectively. And then we are told determine the equation of L3 in the form of y is equals to mx plus c. So we are told that line L3, it is intersecting line L1 and L2 at point A, negative 3, 6. So with this information, that's what we are really supposed to use to be able to calculate, or rather to find out the equation of L3. But there's something that you're really supposed to know, and that is the relationship between all these lines. The relationship between all these lines. And we are told that L3 intersects line L1 and L2 at this particular point, and also at point B, at point P respectively. So L3 is intersecting line L1 at point A, which is negative 3, 6. Okay, this is quite interesting. And what's the relationship between L3 and L1? Because to be able to know the gradient of one of these other line, that is L3, we should be able to know their relationship, because we usually start by working out from what we have to be able to get what we don't have. I remember, or rather if you remember clearly, we already got the gradient of L1, and the gradient of L1 is a half. The gradient of L1 is equals to a half. But let's go back to the starting point of the question and see their relationship. We are told that line L3 is perpendicular to L1 and L2. Therefore, if this one is perpendicular, you are really supposed to know that gradient 1 multiplied by gradient 2 should give you a negative 1. Therefore, that would imply that the gradient of L1 or even L2 multiplied by the gradient of L3, that one should give you a negative 1. And we have the gradient of L1, which is a half, and then multiplied by this, what we don't have, which is GL3, gradient of L3 is equals to negative 1. So to be able to get the gradient of this line L3, which you're really supposed to know its equation, the fact that, rather the reason that we are finding the gradient of this line is so that we can be able to find its equation. Because remember, as we started, I told you that in order to find the equation of any line, you are required to have two things. Number one, it is either you get to have the 2 points of the equation. If you don't have the 2 points of the equation, that is, let's say point A and point B, and you have their actual values, you are supposed to know the value of 1 point. For instance, we have this point here, and also the gradient of that particular equation. So if you have the gradient and you have 1 point, if you have these two things, you can always be able to find the equation of that particular line. If you have these two things, the gradient and 1 point. So what we have already is 1 point, which is a negative 3, 6. So what we are finding now is now the gradient of L3, and the relationship that we are using is the fact that L3 and L1, they are perpendicular to each other, and since we have the gradient of one of the lines, which is L1, we can be able to use the relationship of gradient 1 multiplied by the gradient of L3 is equivalent to negative 1. And what we've done here is replacing the gradient of line 1 by a half, and then we don't know the gradient of L3, and then we say that that one is equivalent to negative 1. Therefore, what we do to remain with GL3, we multiply by 2, such that these two divide by these two to remain with the gradient of L3 is equivalent to negative 1 multiplied by 2, which is going to give you a negative 2, like that. So we already have the gradient already, and we have 1 point. And the point that we are having here is now this point, negative 3, 6, because L3, it is intersecting at this particular point here, negative 3, 6. Okay, and we don't know the other point. If we don't know the other point, we just let it to be xy, but we know that now the gradient of this line L3 is equivalent to negative 2. Let's go ahead and find the change in y divided by the change in x. Change in y over change in x, this is what it's supposed to give us the gradient. That is y minus 6 divided by x minus 3. I believe that this question is becoming a bit much juicy and more interesting, and actually even much simpler and easier as we get to work it out. So this one is equivalent to this gradient negative 2. Actually, you can tell me via the comment sections how you are really feeling about this question. But as for me, I feel like this is really a nice and a very wonderful question to practice with in this particular area of equations of a straight line. So we have y minus 6 divided by x plus 3, because whenever you've got two consecutive minuses, we just change it to be positive, like that. So what we do now here is cross multiplication. We have y minus 6 like that is equivalent to negative 2 multiplied by x plus 3. I think I really need to write this down well so that I can be able to help you in terms of opening that in a way that you'll not make any mistake. So basically, what you're going to get here is y minus 6 is equivalent to negative 2 multiplied by x. That's going to give you negative 2x. And then you have 3 multiplied by negative 2. That's going to give you negative 6. What you have here is y. We can take negative 6 to the other side. But once you do that, it's going to change the sign. So you have negative 6x here. You have minus 6. And then once you take negative 6 to the other side, it becomes a plus 6. And finally, what you get here is y is equals to negative 2x. And then you have negative 6 plus 6, that's 0. So there's nothing much that you can be able to do about that. So if you are to add something, you can only add 0, but this is the same as leaving it as negative, or rather y is equals to negative 2x. And that is the exact required solution for that, because you're supposed to leave it in the terms of y is equals to mx plus c. But since you've been told to leave it in this format, therefore you can just put a plus 0, but notice that this 0 does not have any effect. So the c here is represented by this 0, and then we have the x, and then we have m. M is now pointing to negative 2, and then we have y being on the left side. And that is exactly how you are really supposed to work out on this particular question right there. Let's get on to our final part, which I believe it's a very interesting one, because it is getting to culminate all that we've done in all these parts that are here. Let's see what this part is requiring us to do. You see, in the initial part, we were able to work out the gradient. On the second part is equation. The other part is equation. And now we've got now a question that is asking about determining the coordinates of point P. Coordinates. This is really wonderful, coordinates of point P. Sometimes when you write something, it gets to actually sink more in the mind. It gets to actually sink more in the mind. So to be able to get the gradient of this line, there's something that you're really, or rather not actually the gradient, but the coordinates of this particular point P. What you're really supposed to know is where that point P is located and how it actually associates with the line that we have. So it is from this point that the concept of line P was introduced. And this is the point that we were told that line 3 intersects line L1 and L2 at points A, negative 3, 6, and P respectively. Therefore, that is implying that line L3, it is intersecting L2 at point P. This is really so much wonderful. So what you're really supposed to know is the equation of L3 and L2. Actually, I need to write it down here for you, that L3 and L2 intersect. My cursor is really intersect at P, like that. Because you see L3 intersects line L1 and L2 at points A, negative 3, 6, and P respectively. So that is implying that the line that is, or rather the point at which L3 and L2 are intersecting, it is at this particular point P. Therefore, and this is the concept that you're really supposed to know, therefore the point where these lines are going to intercept at this point P shares something that is common to this line L3 and L2, and that would imply that the equation of L3 and L2, they are equal at this point P. Therefore, the trick here is to be able to find the equation of L2, and let's go ahead and find the equation of L2, which I believe we have already dealt with right here, and that is y is equals to half x plus 5 over 2. Someone should remind me that when I reach to this point. But let me see how well. We say that she's y is equals to a half x plus 5 over 2. Someone should go back there and confirm that, but I believe that is so. But now for L3, I believe it's this one that we were working at this particular instance, because we are determining the equation of L3, that is y is equals to negative 2x. Y is equals to negative 2x. So you're going to realize that this one is a function of y, and also this one is also a function of y. And what does that tell us? That really tells us that negative 2x is equivalent to this other part that is here. That is a half x plus 5 over 2. What should we do to simplify this in a way that is a bit much easier? We can decide to multiply by 2 everywhere to get rid of these denominators, but also then again, we can decide to take a half x to the other side to have, actually we can put this one in decimal form to make it easier, is equals to 0.5x plus 2.5. We take 0.5 to the other side to have negative 2x minus 0.5x is equivalent to 2.5. Okay, seems like we should use just this space that we have here. So negative 2 minus 0.5, that's going to give you minus 2.5x is equivalent to 2.5. That is the one that is right here, 2.5. To get the value of x, we divide by negative 2.5, divide by negative 2.5, and this is going to give us x as 2.5 divided by negative 2.5, that is negative 1. So we have already gotten the value for x. We now need to get the value for y. I believe it's much easier to use this equation. That is y is equals to negative 2x. And we just plug back the value for x here. So we have negative 2 multiplied by x. X is negative 1. Let's go ahead and find out the value for this negative 2 multiplied by negative 1. That's going to give you a 2. Actually, this will give you y is equals to 2. But actually, you can actually pick this one, which is the value for x, which is negative 1, and try to replace it here and work out the value for this function. You should be able to get the same value as y is equals to 2. You can actually try out later on. But for now, let's just complete the equation. We are supposed to determine the coordinates of point P. Therefore, point P is usually now given in terms of x, y. Therefore, that would be equivalent to the value of x, which is now negative 1, and the value of y is equivalent to 2, like that. You see, if you leave it at this point here, that is x is equals to negative 1, y is equals to 2, well, that is correct up to that point, but you will miss the final mark, which is the answer mark, because you are supposed to give the coordinates of point P. And the way that you give coordinates, it's in terms of x and y, where we open the brackets, we put the value of x, then we put a comma, and then we put the value of y, and then we close the brackets. So if you do it like that, then you should be able to get all your full marks for that particular section. And that is how you are really supposed to solve and go about all these parts about this particular question. So you can continue ordering the book that is right on your screen, which is the KCSE Mathematics Daily Mathematics Challenges and Solution Booklet, which is a KCSE revision booklet that is very perfect and very wonderful for your more practice on such questions, and also for general KCSE revision, and also for those who are in lower grades like 7, 8, 9 to 12. There are also other books that have been created to make mathematics easy. Also, you can also get to visit the website, which is countersymathematics.co.ke, to continue igniting your passion and your excellence in mathematics. Right now, you can keep on going with the revision by getting to clear or to click on the video that appears on your screen. There is a thumbnail that is there that you can click to move on to the other clip that is coming up. This is question 20 of the KCSE 2025 Mathematics Paper 1. Sincerely speaking, this question looks like a novel, and actually, to make it worse, it contains very heavy numbers that would actually make someone to be scared. But I want you to just relax like that, because we are going to do some justice to this question, because we are going to crush these numbers and simplify this question just in 3 lines, which will actually make it look like the easiest question you've ever solved of this nature. So just walk along with me as I show you how to take all these 10 marks that do come with this question. So we are told that a transporter was contracted to transport 133 tons of sand from site A to site B. And then the transporter used 2 lorries, a 7-ton lorry and a 14-ton lorry. The transport incurred a cost of shillings 3,000 per trip for the 7-ton lorry and shillings 4,000 per trip for the 14-ton lorry. The total cost incurred by the transporter was a shillings 47,000. And then for part A, we are told that given the 7-ton lorry made X trips while the 14-ton lorry made Y trips, write down 2 equations to represent the information. So that is part A. Yeah, it's always good to have a picture of what else is required. These are something that you're supposed to solve using the matrix method, that is 5 marks. And for the other part over here, there are some details that we are given, and then it tells us to calculate the amount of profit. So this is 3 marks. Here, this is 5 marks and 2 marks. So with that picture in mind, let's just get into part A and do some justice into it. So all this information, you'll be surprised that we can just be able to simplify all these in just 3 lines. Why? Because the information that you are given is involving this 7-ton lorry and a 14-ton lorry. So that's something that is of key interest to us, and that is the 7-ton lorry and this one 14-ton lorry. And is there anything that you are told? The thing that you are told about this is the trips they made and hotels and the costs per trip. You see how simple this is, because what we really need to know is the trips made and costs per trip. Only these, and we'll be able to form some equations. So for the 7-ton, how many trips did this lorry make? We are told that given the 7-ton lorry made X trips, so that's X, and the 14-ton lorry made Y trips, so this is Y. What else? We are told that the cost, or rather the transporter, incurred a cost of shillings 3,000 per trip. So this is 3,000 per trip for the 7-ton lorry. So here what you have is 3,000, and here that's for the 7-ton lorry, and shillings 4,000 per trip for the 14-ton lorry. So what you have here is 4,000. This is exactly what you are really supposed to know. You see how wonderful it is to have a pictorial format of something, because it gets to simplify something, and it makes it look a bit much easier, and also at the same time it's a good point of reference like that. So we have the trips, and also we have the cost per trip. So that implies that if this lorry is making X trips and each trip is taking 7 tons, therefore the total tons that this lorry is going to make is 7 multiplied by X, that is 7X. I'll show you where this is taking us to. And for this one, if every trip is carrying 14 tons, therefore that implies that the total tons, or rather the total weight that this lorry is going to take, is 14 multiplied by the number of trips, which is 14y. Great. So we need to know, have we been given the total mass to be carried? Let's get back here. We are told that the transporter was contracted to transport 133 tons. 133 tons. Therefore, the total number of tons should be 133. By that, you've already formed your first equation. See how interesting this is. Let's get to see if we can be able to form any other equation from that. Well, look at this very keenly. We are told something to do with cost, and we are told that the cost per trip is 3,000 and the trips are X. Therefore, that would imply that the total number of, or rather the total cost that has been incurred by this 7-tonner is this cost per trip, which is 3,000 multiplied by the number of trips, and that would be 3,000 X. Therefore, we write it down. Somehow, this sounds a bit odd, getting to work with something that is 3000x, but I'll show you what we'll do with this one. Let's get to this one. This part over here, for the 14-ton lorry, we are told that it made Y trips, and each trip it's incurring a cost of 4,000. Therefore, the total cost incurred by this lorry, it is 4,000 multiplied by Y, and that is 4,000 Y. Yeah, like that. Quite interesting. And we are told that this amount is totaling to a total cost of shillings 47,000 right here with us. Therefore, that is 47,000. So these are the two equations that we get, and actually the question is telling us to do what? Let's check. Given all that, so I'm avoiding all that, we are told write down two equations to represent the information, and we have our two equations already. But there's something that we've not yet done with these equations. You see, these numbers look very fat, and they look very scaring. So we have to leave them in a format that is a bit much friendly, and a format that is much easier to work with. And the way that we can be able to do that is by getting to simplify these equations. Because you see, 7, 14, 133, they are multiples of 7. Therefore, we can divide by 7, we can divide by 7, and we can divide by 7. Let's see what we get with this. When we divide here by 7, we are going to get x because this 7 cancels with that 7, and then we get a plus here. We retain the plus, and then 14 divided by 7, that's gonna give us a 2, and we have a y is equals to 133 divided by 7, that's gonna give you a 19. On the other side, we have to find a creative way of simplifying this, and the way that we can be able to do that is by becoming an assassinator to numbers. So we have to kill these zeros. But now mathematically what we'll be doing is not killing them, even though that's the term that you people use. But what we are doing is that we are dividing by multiples of 10. So I would say I'm dividing by 10 to remain with 300. I'm dividing by 10 to remain with 400. I'm divided by 10 to remain with 4700. I divide with a 10 again, I divide with a 10 again, I divide with a 10 again, finally I divide with the last 10 again, I divide with 10 again, and 10 again, and by that you are done with the zeros, and now you remain with a simpler equation, and that is 3x plus 4y is equals to 47. You see now this one is much simpler, and it looks a bit much friendly. So the second equation you get is this one, and also you get this one as the other equation. X plus 2y is equals to 19. And if you just write that, then you should be able to get all your full marks for that particular question. So we've already tested some 2 marks, but now we are also remaining with some chunk of it, some big part of the cake that you've not yet tasted. Let's go ahead and unwrap it together. This is part B of question 20. Remember that this is a KCSE question that was recently tested in paper 1 of the KCSE Mathematics 2025. Part B tells us to use matrix method to solve the equation. Normally when many students see the word matrix using the matrix method, they seem to sweat or get worried a bit. Yeah, but now this is the moment that you now get to master how you are really supposed to work through that step by step. So ensure that you do really follow keenly step by step to ensure that you have really fully mastered this, and I believe that you'll be able to do that. So what we are having here is these two equations, and that is where we start from. We start from these two equations that we have. That is x plus 2y is equals to 19, and we have 3x plus 4y is equals to 47. You can imagine from all this information, we've been able to simplify all these just to this and this, just to 2 lines. You see how powerful mathematics is and how powerful numbers are. They can simplify like a whole novel into just a simple paragraph. But let's just keep things moving on. So imagine to get all these 5 marks, what we shall use is just these two equations. But somehow you might get tempted to use substitution method because you can take this two to the other side, or even you may be tempted to use the elimination method where you multiply this one by 2 such that you can eliminate 4y here. But if you do that, know that you'll be doing a very terrible mistake, and what you'll be doing is that you'll be inviting errors because you've been told precisely that you're supposed to use the matrix method. So to use the matrix method, the first thing that you do is to establish a matrix that represents this information, and let's go ahead and do that. So a matrix that represents this information, this is exactly what you do. So you pick the coefficients of each and every element that is here. For x, the coefficient of x, since we don't have any other number presiding before x, we simply take it as 1. For 3, that is 3, we have it here, that is the coefficient of x. And we move on. What's the coefficient for y? For y, it is a 2. Therefore, we write a 2 there. The coefficient for this y, it's a 4. Therefore, we write a 4 there. And we put this one under a matrix like that. And then we write the unknowns that we have here. And that is x and y. But now we have to write it in column form. That is x, y. And I really hope that you understand why we do this. If you don't, let me show you why. That's the matrix that we get. You see, the reason that we do this is because this matrix form is exactly equivalent to this equation. Notice that to convert this matrix to this equation, what we normally do is that we multiply row by column. So that would mean that we multiply 1 by x, we get an x. We multiply 2 by y, we get 2y. And then we have is equals to 19. Same case with the second part. The second part we have it as 3 multiplied by x, we get a 3x. 4 multiplied by y, we get a 4y, and then is equals to 47. So it is more of the same thing. So to be able to work out using the matrix method, there are some things that are mandatory that you are really supposed to know. And the first thing that you're really supposed to know is how to find the determinant of a matrix. The determinant of a matrix. If this has really been giving you some challenges, then it shouldn't ever give you a challenge again, because finding the determinant of a matrix is simply take the first element that appears first here, and that is 1. And then once we take that 1, we multiply it by the number that is exactly at the opposite side of it. We take it diagonally. So if this is 1, we take 4, and we multiply by 4 like that. But this is what we call the main diagonal. So we take the product of main diagonal. The main diagonal is identified by this first element, that is 1 multiplied by 4, and then we minus the product of the remaining diagonal, which is now the secondary diagonal. For this case, it is now 2 times 3. We have it there. How do we get with this? You can go ahead and simplify this fully, because this is 4 minus 6. 4 minus 6, that's supposed to give you minus 2. Be very careful as you work out this, because if you're not careful, you might end up writing 2, and that's incorrect. The value for this is negative 2. So after being able to find the determinant, the second thing that you find is the inverse of the matrix, the inverse of the matrix. And you see, I'm really going step by step, such that everything that you're working out, it is helping us to work out the step that follows. So to find the inverse of a matrix, we usually do 1 divided by the determinant of that matrix. For my case, I'll wish to go directly and fill it in here, but we do 1 divided by the determinant. For our case, the determinant is negative 2. Therefore, we write negative 2 there, and then we multiply by the matrix that we are finding the inverse for. But there's something that we do to this matrix. We transform it. You see what we called the main diagonal, which is 1, 4. We start by interchanging those digits. We just interchange their positions. If this is 1 and this is 4, this 4 is going to move from here to here, and this 1 is going to move from here to here. So it's like these people are exchanging their positions. So what you are going to have is 4 and 1. But now for the remaining elements, we change their sign. This was a positive, therefore it's going to be a negative. This one was a positive, it's going to be a negative, like that. But if this was a negative, we would have written 2. If this was negative 3, we would have written a positive 3. The idea here is that we are changing their signs. Regardless of the sign that they have initially, we have to change the sign that they have. Let's go ahead and simplify this. It's pretty much easier, because what we do here is we multiply 4 by negative a half. Negative a half multiplied by 4. What do you get with this? That's gonna give you a negative 2, like that. What about negative 3 multiplied by negative a half? That's gonna give you, you see, this is negative and negative, therefore negative disappears. Therefore what we are doing is 3 times a half, and that is 1.5. We can just write it in decimal form to avoid having so many fractions over here. So we have negative a half multiplied by negative 2. That's gonna give you 1, because the negatives are going to disappear. And then we have negative a half multiplied by 1. That's gonna give you negative 0.5, like that. So once we get the inverse, the second thing that we do, notice that this was a step 1, and then we find the determinant, we find the inverse of that matrix, and then finally what we do is that we take this inverse that we got, and we just write it here, negative 2, 1.5. I believe that it is becoming much easier for you. We have negative 0.5. If it seems to be becoming harder, maybe once we are done with all of it, you'll see how simple it was. So this is now the inverse of the matrix. This is the inverse of the matrix. You see, once we have this, it is true to say that this value, it is equivalent to itself. That is very true to say that it is equivalent to itself, which is -2, 1.5, 1, and -0.5. Like that, it is equivalent to itself. It is equivalent to itself. So this is something, this is saying something like 2 is equals to 2, and this is true. 3 is equals to 3. Yeah, any number is equivalent to itself. But now, since we want to find the values of x and y using the determinant method, what we have to do is that we have now to multiply these, what we are having here, with these values that are here. Notice that the whole of these, the whole of the left side is equivalent to the whole of the right side. Therefore, if we multiply these with the value that is here, the inverse, it will be true to say that that one is equivalent to the same inverse multiplied by the value that is on the right side. I hope that you understood that. Possibly when I write it down, you'll be able to understand it much better. So what we do is that we multiply by the values that are on the left side. You see, this is the left side. We multiply by the values that are here in this equation on the left side. This is the equation that we are using. So we multiply by 1, 2, 3, 4. I had actually not noticed that it is following each other, 1, 2, 3, 4. That's interesting. So that implies that this question is like doing 1, 2, 3, 4. Allah, let's move on. We have 1, 2, 3, 4 xy. And then on the right side, remember we said we multiply by the values that are on the right side, which is 1947. These are the days before it was known whether you will ever exist. But let's move on with the question. What you will realize is that for this particular case, this is the inverse of this matrix. And you see, when a matrix is multiplied by the inverse of that matrix, what you usually get is this matrix, which is 1, 0, 0, 1. That's what we usually get. Actually, if you wish, you can verify. Actually, I wish we had more time, but you can verify by doing -2 multiplied by 1, you get -2. And then you do 1 multiplied by 3, that's gonna give you a 3. 3 minus 2, that's 1. Let's go ahead. The same case, once you multiply this matrix with this matrix, you're supposed to get 1, 0, 0, 1, like that. What we call the identity matrix. And that is multiplied by x, y, like that. On the right side, what do we get? On the right side, we do our numbers, we do our thing here. And these are parts that you really need to be a bit keen and careful as you really work out this. Yeah, because if you don't, you are likely to make some errors. So what we take is that we multiply the way that this matrix follows each other, what we call row by column. So it's like someone is running and then they fall down. They run and then they fall down. So that's what we use. This is -2 multiplied by what we have here, 19. And then we have plus 1 times 47. This is 1 multiplied by 47. For the lower part, we have 1.5 times 19. As we solve this question, it will help you to be able to solve any other question that you'll ever get that involves solving equations using matrix. So it's important that we do get to follow all along. So we have 1.5 multiplied by 19, and then we have plus, and then we have -0.5 multiplied by 47. That's the matrix we get over here. We move on. This is the identity matrix. You see, when we multiply this matrix with anything, it doesn't change the value of what you are multiplying with. So if you multiply this with this matrix, it's just going to remain as as xy. Can I explain a bit? Possibly, let me do so. You see, when you take this one, you multiply by x, you are simply going to get x. When you take that x plus 0 multiplied by y, it's like adding x to 0, which just remains to be x. Same case with this one. If we want to get the value for this part, what we do is that we usually pick this value, which is 0, we multiply by x, which is going to give you a 0. So for the lower part, it's you are taking 0 multiplied by x plus 1 multiplied by y, and this is going to give you 0 plus y. You see, it's just going to remain as y, so that doesn't change anything. For this part, you can actually even use your calculator if you wish, but it's actually doable even to some extent without using a calculator, because 19 multiplied by -2, that's supposed to give you -38. So you have 47 minus 38. 47 minus 38. So that's gonna give you a 9, like that. Here you have 19 times 1.5. This is like doing 19 plus 19 over 2. 19 plus 19 over 2. So that is going to give you 9.5. So you have 9.5, and then you add it now to 19, which then should give you 28.5. So you have 28.5, and then you have minus 47 times 0.5. 47 times 0.5, that's gonna give you 23.5. So you are having 23 and 28. 28 minus 23, that's like 8 minus 3. 8 minus 3, that's gonna give you a 5. So you get a 5 there. So finally, you can say that x, just the way that it matches exactly here, you see that x is equivalent to 9 and y is equivalent to 5. And you know what? By just doing that, you have your 5 marks already in your pocket, like that. If you follow all those procedures correctly, like that, you see it was just a simple thing, just working around, playing with numbers as you have some fun, and then you have your 5 marks. But that's not yet done. We still have a piece that we've not taken. We've taken the first piece over here, the second bigger piece over here, but also there's a medium piece of a cake that is here that you really need to work out. This is part C. Part C, we are told the transporter was paid shillings 500 per ton of sand delivered to site B. Calculate the amount of profit made by the transporter. We need to work out this. So the transporter was paid shillings 500 per ton. Oops, have we rubbed the question? Was paid shillings 500 per ton, and we are told calculate the amount of profit. So if this person is going to make profit, there's something that you're really supposed to know. And I saw a lot of students making an error at this point, and I'll explain a bit so that you don't also get to fall on the same trap. We are supposed to know the amount of money that this transporter, or rather the person who is owning these lorries, got, which is quite important, and actually that's the starting point of that. You see, he is paid 500, and this is 500, and this is per ton, This is per ton. And how many tons did our guy transport? Let's see. We had it here. A transporter was contracted to transport 133 tons. So therefore, the amount that this person is going to receive is 500 times 133. And this is where a lot of students made mistake, and I'll show you how that happened. But first things first, we have 500 multiplied by 133. That's gonna give you shillings. 133 times 500, That's gonna give you 66,500. You see, when a lot of students were working out these, when they reached at this point, they felt like, they have now completed because they have already gotten the amount that this person was paid, which is true. This is the amount that was paid. But now, in reference to the question, this is not complete. Why? Because what you're really supposed to calculate is not the amount that the transporter was paid, but what you're really supposed to calculate is this keyword that is here. This word carries a lot of things, the word profit. Therefore, to get the profit, you should be able to calculate the total income, which you've done, and then beyond that, you should also be able to calculate the expenditure of this person, the expenditure. Because this is not the profit, this is just the amount that our guy received, but that's not the profit he made. So to be able to find out on the expenditure, you remember in our question, we were told, and let's get back to it, that the cost per trip for this 7-ton lorry, he was using 3,000, and for this one it's 4,000. And then we are told that for all those trips, the total cost that this person incurred by the transport was shillings 47,000. So we have to take in account that the expenditure is 47,000. And actually, to test if you actually did the correct thing as you worked out this question, you can actually take this is 3,000, the cost per trip, and then you multiply by x. What was x? X is the number of trips made. So let's do 3,000 multiplied by 9. We write it here. That is 3,000. Yeah, 3,000 multiplied by 9. This is actually a good way to confirm if you actually worked out the question correctly. 3,000 multiplied by 9, and then you add, I believe the other one was 4,000. Yeah, 4,000. It's right here, this one 4,000, and then we are multiplying that by now 5, which is the number of trips for the 14-ton. 4,000 multiplied by 5. 4,000 multiplied by 5. See if this is going to give you 47,000. If it gives you 47,000, then that implies that the value for x and y that you got in this particular case are correct. If you don't get it as 47,000, then that implies that you are likely to have made a mistake along the way. But I believe that we did the correct thing. So let's go ahead and just confirm. And this is the juicy part and the wonderful thing about mathematics, that you can always be able to confirm whether you did the right thing. We have 9 times 3, that's 27, and then this 1,000. And then we have plus 5 times 4, that's 20. And then we have these 3 zeros. So 27 plus 20, that's 47. Oh, amazing. Yeah, that confirms that we really did the right thing. And actually, you should really appreciate yourself for following along and doing the correct thing. But now, we are not done with this part. What you're really supposed to do is to find the profit. Therefore, we say that profit should be equivalent to income minus expenditure. And that will be equivalent to 66,500 minus 47,000. What do we get with this 66,500? This is like 66 minus 47. That's 19. Yeah, 19. And this is 500 minus 000. That's 500. And this is in Kenya shillings, 19,500. And that is the exact required solution for this part, and that is how you are really supposed to go about this question. A very wonderful question that has given us a lot of practice in terms of getting to form equations, in how we are really supposed to solve equations using the matrix method. And also, in addition to that, it has also helped us to revise and to see how important it is to be keen as you solve questions, and to be able to answer the exact required question without leaving it along the way. So that is it. Ensure that you continue following all along in all the proceedings and in all the questions that we get to post here, because they are there to help you in terms of building the mathematics ability, in terms of building creativity, and also in terms of becoming better and better in mathematics and beyond. Keep watching, keep following. This is question 21 of the KCSE 2025 Mathematics Paper 1. And actually, this is the only question that looks very innocent until you go to part B and C, where you start mixing vectors as if you are doing some baking. But you need not worry at all, because we have all the ingredients that are required to solve this question, and I'm going to show you the easiest way to be able to scoop all these 10 marks easily in a way that will understand, and in a way that will be able to tackle any other given question that involve vectors. So come along with me as we tackle this question. So we have this part over here where we have a graph, and there is a representation of a vector PQ, but in the question it reads as follows. We are told that in the grid provided, the coordinate of point P and Q are 3, 3 and 8, 5 respectively. And then we are told that vector PQ is also shown. I believe that this is now vector PQ, which is shown here. And actually, once you confirm vector P, it's at the point where we have x-axis being 3 and y-axis being 3. Therefore, that's point 3, 3, and point Q is at point 8 and then 5. That's 0.85. So that's really accurately represented there. Let's get to part A. Part A, we are told express PQ as a column vector. Express PQ as a column vector. You see what we are having here is these points being expressed as just coordinates, but now we are supposed to express that in column vector. Column vector is where we usually have a case like this, x, and then we have y like this. This is what we call column vectors. So it's supposed to be vertical column vectors, but for this one it's horizontal. Let's get to this. So we have let me put it in a way that you'll be able to see everything. So we have point P being 3, 3, and point Q being 8, 5. Now, to calculate, or rather to get the value of PQ, what we do take the value, or rather the coordinates of Q, and then we minus the coordinates of P. Why? Because this vector is moving from this point to this point. So that implies, to represent it as PQ, we take this point that is here, and then we minus this point that is here. What's the value for Q? Q is 8, 5. And the way that we now write this one as a column vector is by writing it vertically, where we start with 8, and then we write a 5 like that, and then we lock all that under this simulation that looks like a bracket. And then we've got a minus. This is Q, so now we minus P. P is 3, 3. So we minus 3, 3 like this. Essentially, I hope that you can be able to see this clearly. Essentially, what you're going to get here is now the value for 8 minus 3. That's supposed to give you a 5. And we have 5 minus 3. I believe that should give you a 2. and that becomes the value for vector PQ as a column vector, and that's how really you are supposed to solve that question. Let's get to part B. That is a bit interesting, and I actually love the way that it is really structured. Already we have scooped the 2 marks here, but now we need to have these 4 marks that are here. Let's get into this question. We are told that two vectors A, 3, -1 and B, -1, 4 are such that Ka plus Hb is equals to Pq, where K and H are scalars. And then we are told determine the value of K and H. Let's see what we are really supposed to go about this. So what we are having is Ka plus Hb. So here we have to play around with some numbers, which actually makes it to be so much interesting. Do we have the value for K? Actually, we don't have it, and that's what we are finding. But do we have the value for A? For A we have, and that is 3, -1. Therefore, we write 3, -1 like that. For K, we don't know the value, but when we have Ka, this is the same as K multiplied by A. Therefore, we put our K here. We remember we've got the addition sign here, and then we have H multiplied by B. Which value do we know here? We have been given the value for B, and that is -1, 4. Therefore, we write it here, -1, 4, but all that is multiplied by H. And we are told that that one is equivalent to this value that we have here, which is PQ. Do we have the value for PQ already? Let's get back to this part here. You remember that in this part, the value that we were finding is the value for PQ. And actually, we got it already. Therefore, we are going to substitute here with 5.2, the value that we got. And this is why it's important to be careful in each and every step that you take, because that implies that if you made an error here, you are likely to carry along that error to part B, because this is a tied question. So let's go ahead and simplify this. I believe that we now have all the ingredients that we need to be able to get the value for K and H. But how do we go about this? So what we do is that we see this is like a matrix. So what we do, we multiply everything that is out with what is inside. For instance, for this case, what we do 3 multiplied by K, we get a 3K, and then we have K multiplied by -1, that's gonna give you a -K. For the other case, we simplify it using the same concept, where we multiply H by -1 to get a -H, and then we multiply 4 by H, we get a 4H there. On the right side, for now, there's nothing that much that we can be able to do about it, therefore we just retain it the way it is like that. So finally, to be able to simplify these, we can be able to put them, or rather to separate them, and the way that we do that is by knowing that we have 3K and then we have a plus minus H. So let's write it down. We have 3K plus minus H, that is equivalent to just a minus H, is equivalent to the value that is in the same position with these values that are here, and that is the topmost value, and for our case that is equivalent to 5. We do the same case to other values. We have -K, and then we have plus 4H is equivalent to this value that is here, which is 2. So what we're having now is actually a simultaneous equation, two equations, and we can solve them simultaneously. So we can use whichever method that you feel comfortable with. We can use elimination or substitution, but for me, I feel like using the elimination method is quite much easier and faster, because we can multiply this by 3, and once we multiply this by 3, what we would get here is a -3K . that's negative 3k. We have plus, and then we have 4 multiplied by 3, that's 12h, and then is equivalent to 3 multiplied by 2, that's gonna give us a 6. For these other, the first part of it, we just retain it the way it is because we want to eliminate the k. We have minus h is equals to 5. What do we do so that we can eliminate this k? What we can do to eliminate this k is to add. We add these two equations because once we do negative 3k plus 3k, that's going to be 0. Then we have 12h plus minus h, that's gonna give us an 11h is equivalent to, we have 5 plus 6, that's gonna give us an 11. Then we divide by 11, we divide by 11, we get the value of h as 11 divided by 11, that's gonna give us a 1. Therefore, we have the value for h as 1. But we still don't have the value for k. We can use one of these equations. I feel like this one will actually be much better because it doesn't have a negative where we have a k, therefore it will be pretty much easier to use. So we take it 3k minus h is equivalent to 5. And we already have the value for h as 1, therefore we write 3k minus 1 is equals to 5, and then we take negative 1 to the other side to have 3k is equals to 5 plus this 1, that's gonna give us a 6. We divide by 3, we divide by 3, and we get the value for k as 6 divided by 3, that's gonna give you a 2. So essentially, the values that we get for k is equivalent to 2, and then for h, the value that we get for h is equivalent to 1. I believe that is what the question was requiring us to do, because the question is telling us determine the values for k and h, and we already got the value for k and for h, and that is it for that. Let's get to the final part. You can see how easy it is to work out this question, especially when you get to follow the right procedures and when you just get to work out when your mind is a bit alert such that you don't make some simple mistakes. Let's get to the final part of it. We are told that on the same grid from point P, represent by accurate drawing the sum of vectors k plus hb. K plus hb. This is what we are really supposed to represent, or rather to work out. So what we are having here is PQ. PQ, but now what we are supposed to represent there, let's see what we are supposed to represent here there. We are told on the same grid from point P, represent by accurate drawing the sum of vector KA plus HB. You remember KA plus HB. What did we get by working out this KA plus HB? That's giving us PQ. And PQ, that is given by 5, 2. But you are really supposed to know the real value that is contributed by vector KA. And let's check out KA. You see that we've gotten the value for K being 2. And the value for A, what was the value for A? The value for A was 3, negative 1. So KA, it's going to be given by 3 times 2, that's 6. And we have 2 multiplied by negative 1, that's 6, negative 2. And HB is supposed to be given by the value for H. The value for H, we got it here as 1. So we have to write 1 here. What about B? the value for B, that was -1, 4. This is actually will give you a confirmation whether you actually did the right thing in terms of getting to solve the value for K and H. And let's see that. Because this is 1 multiplied by -1, that's going to give you a -1. And we have 1 multiplied by 4, that's going to give you a 4. So if you add these two, it's supposed to give you 5, because once you add 6 plus -1, that's going to give you 5. And once you add this 4 to this -2, it's going to give you 2. Therefore, that implies that the values that we got for K and H, they are really true. And that is K is equivalent to 2 and H is equivalent to 1. Therefore, those are the true values for that. So those are the values that we are going to use here to be able to represent what is required in this question, and that is representing the sum of vectors Ka and Hb. And let's go ahead and do that. So the values that we've carried along is 6, -2, that's the value for Ka, and the other value that we've carried along is -1, 4, and that's the value for Hb. Let's represent that. So this upper part represents the x-axis and this one the y-axis. If it is positive, therefore that implies that this point P, it is shifting towards the positive side of x, and it is like a summation to it. So if this is point P, therefore we should count 5 or rather 6 points from this point as we add it towards the right side. So let's go ahead and do that. So it's going to move, or rather to shift, the first position, the second one, the third one, the fourth one, the fifth one, and the sixth one. So this one should be the sixth one. That is 1, 2, 3, 4, 5, 6. So that implies that it will be along this line. But we need to be able to locate the actual coordinate for that along this line. We should also consider this second part. And actually, this is a very wonderful example because it is very balanced. Because you see, this one was a positive, but this one is now a negative. What about a negative? What should we do? For a negative, that would imply that the value for y from this point, it is going to reduce. Therefore, if it was 3, it is going to reduce by 2 units. Therefore, it reduces by 1 unit to this point, and then it reduces to this point here by the second unit. Therefore, it's supposed to be along this line. And therefore, where these two intersections are going to intersect, that's now the point where point P is going to be drifted, and therefore that implies Ka is moving like that to that direction, and you have to indicate that it is flowing in that direction, and that becomes Ka like that. Great. So what we're having is, check at this point, we're having Ka plus Hb. Hb, we've seen that it is -1, 4, -1, 4. And actually, you're going to realize that when you take this one, this point over here, if you reduce this point by 1, that is the x-axis, it's going to drift to this point. Once you drift this position here by 1 towards the left, it's going to be at this point. And we are having the y-axis moving positively by 4 units. Therefore, it is drifting by 4 units. 1, 2, 3, 4. So this is actually very interesting because you'll see that it is drifting to this point. And therefore, this is the real legitimate position of Q. And you have to indicate that that is point HB like that. You see how interesting mathematics is, because you can always work out something and be able to confirm your answer because mathematics gets to add up, and we always say that numbers never lie. So if you make a mistake somewhere along these lines, you are going to notice, or rather to spot, that you made an error when you come to plot here and realize that things are not adding up. By the fact that you did everything correctly, then everything should be able to add up here. But let's keep things moving and check at the final part what we are asked to work out. So in this final part, that is part C, we are told determine the magnitude of vector A, of vector KA, of vector KA. And what's the value for vector KA? Vector KA, it's this one that we worked out here. And that is 6, -2. So you have to know how to find the magnitude of a vector. So how we find the magnitude of a vector, we usually take the x value that we have here, or rather the change in x, and then we square it, and then we add to the value of the value that we have for y, and then we square that, and then we find the square root of that. So let's go ahead and do that. So for the values that we have here, it is 6, and then we square that, and then we add to -2, and then we square that, and then we find the square root of that. What do we get here? We get 36 plus, we have -2. All of these is a squared, therefore it becomes a positive, and you get a 4 there. You find the square root of that. That becomes the square root for 40. Let's go ahead and indicate that right here. Becomes root 40, and this can be expressed as, you see what we have here is 4 multiplied by 10, and we are finding the square root of that. So this is equivalent to root 4 multiplied by root 10, and this is 2 root 10. If you wish to simplify it further, you can leave it in decimal format. Here you find the root of 10, then you multiply by 2, and that is going to give you 6.325 units. And that becomes the value for that. But just before we end this session, let me show you something, because you are likely to get a different case in maybe another paper that you'll be doing. Suppose that you are given point A, and point A, suppose that point A is something like 3, -2, and you are given B is equivalent to, suppose, something like 6, 5. And then you are told find the magnitude of AB. How would you work out this? So what you would work out this is by taking x2, you minus x1, and then you square that, you add to y2 minus y1, and then you square that, and then you find the square root of that. You can actually do this practically for your practice. For our case, we are going to treat this one. Let me actually show it to you. We are going to treat this one as x1, and this is x2, this is y1, and this is y2. So you pick x2. x2 is 6, so that implies that you would take 6, you minus 3, and then you square that, and then you add y2. What's y2? y2 is 5, you minus y1, which is 2, and you have to be very careful on this such that you minus it correctly, because you see these will be two consecutive minuses that are following each other, and whenever you've got a minus sign that are following each other, you know what to do. Then you square that, and then you find the square root of that, such that you've got a 3 there that is squared, and then you have a plus 5 plus 2, that's 7, you square that, and then finally you find the solution for that. So you can also get a case like this one, that is requiring you to find the magnitude of 2 points like that. For this one, we just did it directly because it's already given as a vector Ka that you are finding the magnitude of it. And that is exactly how you are really supposed to talk about that. We'll continue uploading some more tutorials regarding vectors and more areas in mathematics. Here is a very, very wonderful question on statistics too that should actually leave you smiling and having some fun with statistics. It's actually question 23 of the KCSE 2025 Mathematics Paper 1. And let's get into it. And this is a question that is actually having a walkthrough of almost everything that is covered in statistics, because it's asking about getting to draw the frequency distribution table. It's also having some part where you are supposed to calculate the median, the mean, and also it will also get to expose you on some application questions on statistics. Therefore, it's important that you get to stick all along from the start till the end of this question, and you be very in and follow with a lot of focus. Let's get to it right away. We are told that the quantity of petrol in liters used by 40 boda boda riders on a particular day is follows. So we have quite a lot of data there. And the question goes ahead and tells us that the cost of 1 liter of petrol is shillings 1.6, or rather 1 shillings 160. And then part A of the question tells us that starting with 1.5 liters and using a class size of 0.5, draw a frequency distribution table for the data. You see, this data is quite so much scattered, and which makes it a bit so much unorganized. So we need to organize it so that you are even able to calculate the subsequent parts of the question. And to organize that, what we do is that we draw the frequency distribution table for that data. And actually, this is one of the most important parts of this question, because it actually forms the backbone for the rest of the parts, because everything else that we are going to calculate here, we are going to do that in reference to the table that we are going to draw. And let's go ahead and draw it. So to be able to draw the frequency distribution table, there are three important things that are very important that are really required. Number one is having the least figure out of the figures that you have. You should be able to know the least amount, or rather the least figure out of the data that you have. So that's the first thing. The second thing is to know the maximum figure out of the data that you have. And finally, the third thing is to know the class size of that data. Let's go ahead and try to identify all those three things. So we try by first checking out the first row, or rather this is actually a column. We check this column to see if it's going to give us the least value. The least value here is 1.7. The least value here is 1.5. The least value here is 2.1. The least value here is 1.5. The least value here is 2.0. The least value here is 1.5. The least value here is 1.8, or actually 1.6. The least value here is 2.3. So out of all these, I see that the least value that we have there is 1.5. Therefore, that's the least value that we have. What about the highest value that we have amongst all these? Here it's 4.0, here it's 4.1, here it's 4.3, here it's 3.7, here is 3.4, here is 2.6, here is 3.2. So the maximum figure that we seem to have amongst all these numbers, I feel it's 4.3 actually. So the highest number that we have there is 4.3. And the third thing that you're really supposed to have is now the class size, which is 0.5. So once we have this, we are good to go, because this one is going to help us to have the column for the ranges, which is actually the first row that we should always have, and it should also appear in the first row and in the first column. That is what we have as the range. So the other thing that we are really supposed to have in a frequency distribution table is the frequency. So we put there the frequency. The that thing that you're really supposed to have is to have the middle value. That is what we call x. And finally, we are really supposed to have the product of these, that is fx. Yeah, but also it's also important that we also have the cumulative frequency, because we are going to use that. So we start by identifying the ranges that you are really supposed to have. And actually the question has done some good work of telling us that you are really supposed to start with 1.5 liters. Therefore we put a 1.5 there. And we are told that the class size is 0.5. So for the class size to be 0.5, what we usually do to identify the range is that we take this one, 0.5, and then we minus 0.1. That's going to give us a 0.4, and then we come here and add 0.4 to this number that we have here. That's going to give us 1.9. And then the other range that starts here, it should start now with 1.5 plus 0.5, and that's 0 point, or rather 2.0. So we put a 2.0 there. And it's moving from 2.0 to now 2.0 plus 0.4, that's 2.4. And we have 2.0, the other range, it's going to start with 2.0 plus 0.5, that's going to give you 2.5. And then it's moving all the way to 2.9. What about the other range? We need to put this in a way that we can be able to utilize the whole space well. The next range is 3.0 to 3.4. I believe that you've already gotten the trend on how we are really supposed to shift about this. The other one is 3.5 to 3.9. The other range is now 4.0 to now 4.4, and actually this one should be the last one, because there's no any number that is exceeding 4.4, and that is why it's important to know the maximum number that is in these values that we have there. So having this, we are going to form a tabulation to this, and the way that we form a tabulation, you make it to be a table. And it's always important that you get to utilize the space that you have all here. So if for your case, I know that you could be having a ruler, so you just go ahead and utilize it to have something that is a bit so much presentable, and something that someone would enjoy marking by drawing some good straight lines. For now, I'll go ahead and sketch a table like that. It may not have some straight lines, but it will be good, and it will help you to show you how you should do it. We have all these sections, you get to separate them like that, and also you make it fully a table so that you can be able to have some figures in between there like that. So we still have some three lines like that. Yeah, you see it looks like a very wonderful table, but somehow like a net, I don't know. Yeah, but let's get to the main thing. What you're really supposed to first calculate here is the frequency. And how do we calculate the frequency? We calculate the frequency by counting the numbers that lie within this range of 1.5 to 1.9. And let's go ahead and do that. Any number that is lying across 1.5 to 1.9, we go ahead and get to take it out. So we have the first one, 1, 2, 3, 4, 5, 6, 7. Do you have any other number? Not really, don't have any other number that lies between 1.5 to 1.9. Therefore, we put a 7 there. We go ahead and check the numbers that lie between 2.0 to 2.4. Let's go ahead and check them. At this column, we don't have. Here we have the first one, 1, 2, 3, 4, 5, 6, 7. 7. You have to be very careful. 7. Do you see any other one? 7. Yeah, we have another one here. 8. Essentially, you'll be able to tell because at the end of it all, every number should be circled, and you'll see if there's a number that you opted out. So the next series, or rather the next range, is 2.5 to 2.9. 2.5 to 2.9. So we have the first one here, 1. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11. Oh, that's really quite a number of them. The next one is 3.0 to 3.4. Let's check together. And actually, as we do this, it will help you in terms of being focused as you check at these numbers, and also it gets to sharpen on your keenness as you do that. So the first one that you are able to identify from here is this one. 1, 2, 3, 4, 5, 5, 6, 7. So that's 7. We go ahead, 3.5 to 3.9. 3.5 to 3.9. We don't have there. Here we have the first one. Here the second one. Third one. Fourth one. Yeah, so that's only 4. So we put a 4 there. Finally, 4.0 to 4.4, we have the first one, the second one, the third one. Do you have any other? No. And actually, all numbers have been circled. So that implies that what we've done is really correct. So the next thing that we find is the mean value of this range. So to be able to find x, what we do is that we take 1.5, we add to 1.9, and then we divide by 2 to find the middle value that appears here. So let's go ahead and do that. That's 1.5 plus 1.9. We divide that one by 2. That's going to give us 1.7. So we put a 1.7 here. So I'll go ahead and tell you the values that lies around here. This is 2.0 plus 2.4. Once you add, you are going to get 4.4 divided by 2. You get 2.2. And actually, you are going to realize that there is a pattern that lies also here. Since the difference between these two values is 4, therefore that implies that the middle value lies at a point where we have a 2, where we have a plus 2 or a minus 2 from the left side. So you can always take 2.5 plus 0.2 to get the middle value that lies here. So that will be 2.7. For this case, that will be 3.2. For this case, that would be 3.7. For this case, that would be 4.2, like that. So fx, that's when we take the frequency multiplied by the middle value. For our case, we have 7 multiplied by 1.7. That's going to give you 11.9. You have 8 multiplied by 2.2. that's going to give you 17.6. You have 11 multiplied by 2.7, that's going to give you 29.7. You have 7 multiplied by 3.2, that's going to give you 22.4. We have 4 multiplied by 3.7, we get a 14.8. We have 3 multiplied by 4.2, that should give us a 12.6. Finally, we are supposed to calculate the cumulative frequency. But how do we calculate the cumulative frequency? We usually take the first frequency for our case, that's 7, and we put it there, and then we take the subsequent frequency for our case, that is going to be 8. So we do 7 plus 8, and that's going to give you a 15. And then we take 15 plus this frequency that lies here. So 15 plus 11, that's 26. So you should never have some challenges with calculating the cumulative frequency again, because it's just a matter of taking the first frequency and then you add the frequency that follows consecutively, and that is why it's called cumulative, because it is cumulating together. So we have 26, we add a 7 there, that's gonna give us a 33. We have 33 plus 4, that's going to give us a 37. We have a 37 plus 3, that's going to give us a 40. And finally, we can find the summation of all these. We can add these frequencies, that is 7 plus 8, 15, plus 11, 26, plus 7, 33, plus 4, that is 7, plus 3, that's going to give you a 40. What about for x? We might not require to use this one later on, but we might need to use the cumulative, or rather the summation of fx. So we add 11.9 plus 17.6 plus 29.7 plus 22.4 plus 14.3 plus 12.6, and that is giving me 109. Finally, we might not need to have the summation of CF and X, so we can leave it at that for now. And actually, this is the required frequency distribution table for that number. So if you are able to do that, then you should be able to get all your full marks for that question. And this forms the backbone for now, everything that we are going to do after this. We are going to do that in reference to this table that we have here. And let's go to part B, Roman 1. We are told, use the frequency. Actually, you can see that the question is referring you back to the frequency distribution table. So that implies that if you really made some mistakes here, you are likely to carry them all along in the subsequent parts. So part A, Roman 1, tells us to estimate the mean amount of money spent on petrol by the boda riders of that day. So we are supposed to calculate the mean. So we should be able to know how we calculate the mean. So to calculate the mean, what we usually do is that we usually take the summation of fx, we divide that one by the summation of the frequency, by the total frequency. Let's go ahead and do that. The summation of fx, which we've calculated here, it's 109. Therefore, we do 109, and then we divide that one by the summation of the frequencies, which is 40. And actually, I believe that in the question that we were told that it's supposed to be 40 boda riders, which we are able to confirm from this, and that tells us that we've really done the right thing. So we divide by 40 there. So once we do 109 divided by 40, that's going to give us 2.725. And I remember that this is dealing with petrol. Therefore, we have to give the units for that to ensure that we don't leave any room to be penalized for that. So that's the exact required solution for that. And now we have the part 2 of it. We are told that estimate the median amount of money spent on fuel by the median boda rider. So one thing that you really need to know is the median boda rider, how much fuel that that person spent. So we should be able to calculate the median value. And to be able to calculate the median value, we should be able to have the formula for doing that. And to calculate median, what we usually do is that we always take the lower bound of the median class, and then we add that one to n over 2. This is a formula that you should have in case it gives you a challenge. You can get to write it down and practice as much as possible so that it can be able to stick, and also so that you can be able to use it in different scenarios. But basically, to calculate the median value, you usually take the lower bound of the median class, and then we add that one to n over 2, where n is now the total number of boda for our case, and then we divide by 2 minus the cumulative frequency above. You have to notice that this is above median class, and then we divide that with now the frequency of the median class, and finally we multiply these results that are here with the height of the median class. I believe that we can go ahead and do that. But now to be able to know the median class, we should be able to do n over 2. And what is n over 2? N over 2, this is how we calculate n over 2. N over 2. So our n here is 40. So we do 40 over 2. And this is going to give us a 20. So we check at this column where we have cumulative frequency, we check where 20 would lie. It can't lie here because there's a bigger number here. And then you see that 20 has surpassed 15. Therefore, that implies that the median class is going to be this one here. This one is what we are going to have as the median class. Very, very important. This one. So let's go ahead and work out this. What's the lower, or rather, what's the lower bound of the median class? You see the median class, it's this one that is right here. So the lower bound for this one, if this one is 2.5, so what we do 2.5 minus 0.05 to be able to get the value for that, and that will give us a 2.45. Therefore, what we use here is 2.45. Remember, we are adding that to n over 2. N over 2, we got it as 20. Yeah, you remember that we worked it out here. This one over here, we got it as 20. Therefore, we do 20 minus, this is a part that we now need to be careful a bit, a cumulative frequency above median class. So we have to go to where we have the cumulative frequency, and we have to go to the place where we have the median class, and then we check the value that appears before that, and that is 15. Therefore, what you are going to minus here, it's a 15. And then we divide that now with the frequency of the median class. What's the frequency of the median class? We have it right here, and that is 11. The height of the median class, that is exactly the class size. And you remember that we were even told that the class size is 0.5, and that's what we used here. Therefore, we go ahead and plug in our 0.5 here. So let's go ahead and write it down there. You see, sometimes you can have the right formulas and you have the right values, but once it comes to opening the brackets, you make some errors which might make you to lose a number of marks out of the 4 marks that we have here. Therefore, we also have to be very keen as we get to open up these brackets as we get to solve out this one. So we have 2.45 And then we have 20 minus 15. That's going to give us 5/11. And we have that one multiplied by 0.5. Let's go ahead and simplify this. So we are getting 2.45, and then we are adding that to, you can pick up your calculator and do 5 divided by 11 multiplied by 0.5, and that is going to give us 0.2, and then we have 272727. It's actually a recurring decimal. So actually we can pick this one to how many decimal places? To 1, 2, 3. We can pick it up even to these decimal places. So we have 2.45. We add to this. Let's see what we get. That's going to give us 2.677. Yeah, because 4 plus 2, that's 6. 5 plus 2, that's 7. And then we have this 7. Therefore, that should give you this. So this is the median, or rather, this is the median value of the fuel that was consumed by the median border. But you have to be very careful, and here is a very, very dangerous trap that has been put there, because most of the questions usually ask about getting to calculate the median amount. But now for this particular question, it is telling us to calculate the median amount of money. This is a very critical statement here, amount of money. You see, if we leave it at this, and actually many of the students left it at this is incorrect because it is incomplete. Therefore, we have to go ahead and work out the question completely. So the question is telling us the median amount of money. So what we have here, this is in liters. So to get the amount of money that was spent for that, we have to take 2.677. We multiply that by the amount of money that this person was paying for every liter. And have we been given that? We are told that 1 liter of petrol is shillings 160. Therefore, we have to remember to go ahead and multiply this one by 160, and let's go ahead and do that. So we multiply by 160, and what do we get once we do this? Once we work out this, it's supposed to give us Kenya shillings for 28.32. And if you do that, then you should really be able to get all your full marks for that. So you've been able to get all these 4 marks, the 4 marks there, and the 2 marks that are hidden here, and that makes the 10 marks in that question. You see how easy it is to solve a statistics question, especially when you get to follow the right procedures and when you are a bit keen. So what this question required you to do is to be very attentive as you get to solve it. And actually, we've solved more and more questions here in this channel. Continue to check them out and ensure that you do follow along in everything that we get to upload here, because everything that we get to upload here is what we find to be so much valuable, and what has really been demanded by a lot of students. So you can feel free to comment with areas that you'd like to be covered next, and we'll be sure to check out on them. For now, ensure that you get to click on the video that is appearing next here. There's a thumbnail that is there. Just click on it to continue learning here with Composite Mathematics, where we make mathematics fun and enjoyable. One of the best ways to practice mathematics is to do some application questions. And here is a very wonderful question that is going to help us in that. It's actually question 24 of the KCSE 2025 Mathematics Paper 1. And we have it right there. Sometimes mathematics can be a bit interesting because in some questions you can be a surveyor, in other questions you are an engineer, in other questions you are a doctor, in other questions you are a business person, but it seems like in this question we are going to act like a surveyor, because I see that we've got a structure here. But let's go ahead and read the question and see what this is all about. We are told that the figure ABCDEF represents a plot of a land with length AB is equals to 50 meters. We have it AB 50 meters, BC is equals to y centimeters, that is BC is equals to y centimeters. We have CD is equals to x centimeters. We have CD right there. And we are told DE is equals to 40 meters. DE. Where do we have DE? DE is right there, 40 meters. And then we are told that the figure also shows an adjacent plot of land BCDG. And we are told that all angles in the figure are right angles. And then on the second part of it, we are told that the owner of the plot ABCDEF later purchased plot BCDG, and we are told that given the perimeter of plot BCDG is 60 meters, and then we are given some questions from that information. So we've got quite some parts over there. And this is really so much amazing because it's involving area, it's involving perimeter, it's involving differentiation, it's involving expressions, it's involving equations. So it's really having a lot of things. And that makes it to be a very, very wonderful question to help us in terms of doing some practice with the application question. But let's start with what we have to get what we do not have. So for this part that we are given here, we are told that the perimeter of plot BCDG, you should be able to locate that BCDG. BCDG, we are told that this perimeter is equivalent to 60 meters. So for part A, which is a really wonderful part, we are told to write an expression for y in terms of x. So one thing that you're really supposed to check out is where the y and x come into this equation. So for our case, we are having y here and x here. So to be able to write an expression for y and in terms of x, we should be able to write an equation that is involving y and x. And the way that you can be able to do that is to use this information that you've been given here, and that is the perimeter of this plot that is here. I believe that you can be able to see it. That is BCDG is equivalent to 60 meters. But how do we find the perimeter of this? If this is x meters, therefore that would imply that also this part is x. If this is y, therefore that would imply that from G to D, that's y. So that would imply that x plus this x, that is x. It's important to indicate that x plus x plus this y from here to here, and y this part from G to D, that is y plus y. That one should give us a perimeter of 60 meters like that. So we can go ahead and simplify this equation that we have here. And we are going to have 2x plus 2y is equals to 60. So we can go ahead to simplify that by dividing by 2, divide by 2. Here we have 2 divided by 2, we remain with an x. And here we have got a plus. We've got 2 divided by 2, we remain with y is equals to, on the right side we have 60 divided by 2, that's going to give you 30. But now the question is telling us, write an expression for y in terms of x. Therefore, what we are supposed to have on the left side is a y. Therefore, we are going to take x to the other side, but remember that wherever it crosses this equal sign, it must change the sign. So it was a positive, it's going to be a negative. Therefore, you're going to have 30 minus x. And that becomes the expression of y in terms of x. And if you write that, that is quite satisfactory, and that's the required solution for that. Let's proceed on. And actually, as we do this, if this is actually a real life scenario, and then you make some errors in terms of getting the estimates for this, or rather the actual values for this, then this is a case that would actually land you in a court. If you take the wrong measurements and then you assume like you get measurements that are directing you that your plot is starting from here to here, and then you go and try to fence and see what is really going to happen. Therefore, that's why we really need to be very careful and keen as we work out this, because it is a replica of a real life scenario. Let's get to part 2. Part 2, we are told, write down a simplified expression in X for the area of the entire plot of land AGEF. Can you be able to locate where AGEF is? Yeah, I believe so, because we have A here, we have G here, we have EF, so it's for the entire land. So that would imply that the length from here to here, that should be this 50, which is the length from here to here, plus this X. Therefore, that is 50 plus X. And what about the width? That is 40 plus y. Therefore, the width is 40 plus y, like that. So let's go ahead and work out the area for this one. So to calculate the area for that, we are going to take it normally the way that we usually have length multiplied by the width. So that would imply that we'll have 50 plus x. Yeah, you just need to be so much relaxed as you do this question. You need not panic at anything, because it's a matter of applying the knowledge that you know, that the area we get it by length, by width, only that the structure is a bit different and it's having some variables, or rather some constants that are unknown, that is x and y. So we have 50 plus x, which is the length, we multiply by 40 plus y. But you have to look at this very keenly. We are told that we are supposed to write down a simplified expression in x for the area of the entire plot. So to be able to do that, we must be able to transform this y to be in terms of x. And let's go ahead and try to do that. So the way that we are able to do that is we first pick 50 plus x, it remains like that, and then for the second part, 40 plus y, notice that we had already gotten the value of y in terms of x, and we have it right there. So instead of writing this y, we are going to write 30 minus x. So that's what we write there, 30 minus x. Let's go ahead and open up these brackets. We have 50 plus x into brackets, and then we have the second part, that is 40 plus 30. That's going to give us a 70 minus x, and you see we have an expression of the area in terms of x. But if you look at the question very keenly, it's requiring you to write it when it is simplified, and you see this one is not simplified. To simplify this, we really need to open up the brackets. And the way that we open the brackets, we usually take the first element that is in the first brackets. For our case, that is 50, and then we multiply by everything that is in the second bracket. For our case, that is 70 minus x. And then we take the second element that is in the first bracket. For our case, that is x. Therefore, we write plus x. And then we take everything that is in the second bracket. And for our case, that is 70 minus x. We write it there like that. So let's go ahead and open up the brackets completely. We have 50 plus, or rather 50 multiplied by 70. That's going to give us 3500. We have 50 multiplied by negative x, that's going to give us negative 50x. And then we have a plus x multiplied by 70, that's 70x. And then we have x multiplied by negative x, that's negative x squared. So this is the expression that we are really getting. So we really need to go ahead and simplify it further. And the way that we simplify it further is by getting to simplify this part. For this initial part, there's nothing much that we can be able to do about it, therefore we can leave it at that. And also for this one, so therefore what we get is 3500, and then we have negative 50x plus 70x, that's going to give you 70 minus 50, that's 20, a positive 20x. And now here we have minus x squared. So if you leave it at that, that's very correct. But then again, if you wish, you can rearrange it to fit the standard form of a quadratic equation, because we see that what we are having here is the quadratic equation, where we start with x squared and then we have plus 20x and then plus 3500, like that. And that becomes the simplified expression in x for the area of the entire plot of land AGEF. By just doing that, you already have your 3 marks there, and we have our 1 mark there, and I see that we still have some more marks to hunt for, and let's go ahead and check out what we are having here. Yeah, but the idea is that you should really be able to integrate everything that you know as you tackle this question, because it's really requiring you to connect different ideas from different concepts and from different areas. So for the second part of it, part 1, we are told determine the dimensions of plot BGDC. BGDC, we need to see where that is. When you see something, it becomes easier to comprehend it. BGDC. So it's this one, the small one. Okay, that's really awesome. Let's go ahead and see what we have. Determine the dimensions of plot BGDC. That would maximize the size of the entire plot AGEF. That would maximize AGEF. You remember that AGEF is the entire plot. This one, AGEF, it's the entire plot. And actually we have an equation for that, which is this one right here. So to be able to find out the dimensions of this plot that would maximize this equation, there's one concept that you're really supposed to know, and that to be able to get the maximum value, we should be able to know that the gradient at that point should always be equal to 0. Therefore, that implies that the change of y over change in x over this equation right here, it should give us a 0. That's only what you're really supposed to know, and actually that's what's going to lead us to a point where we'll be able to maximize the size of the entire plot. Therefore, we should be able to find the gradient of this equation that is right here. Remember, to find the gradient of an equation, what you usually do is that you usually take the power that is there at the number, and then we multiply it by the constant that is there. For instance, for our case, the one that we have here, the coefficient that we have here is -1. Therefore, we are doing -1 multiplied by 2. That's going to be -2. And then we write the variable that is there. For our case, that's x. And then we reduce the power by 1. This was 2 power 2. It's going to be 2 power 1, like that. And then we have a plus. The same case we do with this one. You see it is 20x, therefore the power for x is 1. Therefore what we're having here is just 20 multiplied by 1. That's going to remain as 20. And then we have x. The power was 1. We reduce by 1. Therefore it's going to be 2 power 0. So essentially what we are getting here is -2x plus, anything to power 0 is equal to 1. Therefore, this is like 20 multiplied by 1, and that's going to give you a 20. And we remember that we've said for it to be maximum, this one must be equivalent to 0. Therefore, it's true to say that 0 is equal to -2x plus 20. So we can go ahead and simplify this. We have -2x, we can take it to the left side to have 2x is equals to 20. We divide by 2, we divide by 2, and we get the value of x as 20 divided by 2, that's 10. But there is a value that we don't have yet, and that's the value for y. Therefore, we have to get the value for y. And how do we get the value for y? We use the equation that we had initially gotten. You remember this equation that is right here. That is y is equals to 30 minus x. That's the equation that we use. So we have y is equivalent to 30 minus the value that we've gotten here for x. You see, we've gotten the value for x as 10. Therefore, that's what we are going to substitute over there. Therefore, we have 30 minus 10, and that is going to give us a 20 like that. And that becomes the value for y. So essentially, we go back to the question and see what the question was telling us to find. The question was telling us determine the dimensions of plot BGDC, the dimensions BGDC. Let's see where BGDC is. It's actually this one, the mini area that is here, BGDC. So to be able to tell out the dimension of this, we tell it in terms of length by width. So the dimension would be that the length, remember, the length was the length equal to y or x. We see that the length is equal to x. The length is equal to x, therefore that is 10, and that is meters. And then we have y, that is 20 meters like that. We really need to confirm this, that y is the width, and I believe that's what we've really given out here, and that is what you are really supposed to give out. But again, you can just say it is 10 meter by 20 meter. That would also be so much accepted. But now I see that you've got now the final part, which is here. Oh, I don't know why they gave out some small space for this, but let's check it out. We are told, and actually this is the last printed paper, okay. We are told determine in meters squared the maximum possible area of plot AGEF. Let's see where AGEF is. You see AGEF, it's actually this one over here. AGEF, it's this one, entire one. So, and we know that its measurement, it's in terms of 40 plus y multiplied by 50 plus x. That's 40 plus x. And is it actually 40 plus x? It's actually 40 plus y. 40 plus y multiplied by 50 plus x. We have already the value for x and y, so we just go ahead and simplify that. So we have 40 plus y, so that's 40 plus y. What's y? 20. And we have 50 plus x, so that would be 50 plus x. X is 10. So this gives us 40 plus 20, that's 60, multiplied by 50 plus 10, that's 60. And I remember this is 60 meters multiplied by 60 meters, and that is definitely going to give us, that is 600 meter squared. And that is the exact required solution for that particular question. And that is exactly how you are really supposed to solve this question. So there is video that is popping up. There's a thumbnail that is there on your screen. You can get to click on it to continue enjoying some tutorials from KCSE Mathematics, where we continue to make mathematics fun and enjoyable.